Alright, welcome to your very first lecture on the tkinter module. So the tkinter module is actually where the basic or the main GUI programming happens in Python. And using this module, we can create some fantastic looking applications, games, etc. as we progress along into this course. So let's get started. First thing first, make sure you don't use the shell at all. Definitely open up a new file if you're wondering how. File, new file, and you'll get a file like this. So what I'm going to do is I'm going to go ahead and minimize this. Alright, make this a bit bigger. Alright, so the way this is going to work is the first command is to import tkinter into our whole file. Alright, so we need the tkinter functions, we need all that to work, so let's go ahead and do that. Instead of writing import tkinter, what I want you to do is write from tkinter import star, and all this does is it says, hey, make sure you get everything, don't leave anything behind, import everything from the tkinter module. Alright, so the next thing is we want to initialize that screen, okay, that basic screen that you always see in a tkinter module, the minimize sign, the maximize sign, and the close sign, stuff like that. So to do that, we're going to call the function or call the statement. You can give your window any name you want. You can call it app, you can call it root. Most people call it root. And root will now be equal to tk. So all this means is, hey, I want to initialize the tkinter interface. I want a window to open. And this is basically all it does. Now, the next thing we want is we have this window and it's fantastic. So let's go ahead and run the program and see what happens. So it asks me source must be saved. Okay. Go ahead and save the program to your liking. Call it tkinter test, tkinter 1, section 1, whatever you want to call it. I'll call it tkinter 1 in documents. Hit save. And now that we run it, it goes back over here. And your Python launcher, does something happen? Yes, it does. So your Python, for me, it's a rocket ship, but that should now load. And if you open it, you now have this very cool looking tkinter interface. Alright, so this is the whole concept of the tkinter module. You initialize it, you create, you add elements, you add widgets to your whole interface, add background colors, make things move, stuff like that. So very cool. In this lecture, we created a very simple tkinter window. Alright, and right now this is, well, very basic. There's nothing to it, there's nothing in it, but it works and that's all we care about. So let's minimize this and take a look at our code. Alright, so from tkinter import star, that basically imported everything we needed from the tkinter module. And then after that, we used root is equal to tk to initialize that app, that window. Now, in case your window is not appearing, in case it's going away really quickly, the way to solve that is called the main loop function. And all the main loop function does is it says, hey, don't make the window go away until the user presses the X button or closes the window. So hitting F5, save the source, and then the Python launcher launches again. So as you can see, this restart has happened. And opening our Python launcher, again, there's no change to it, but in case you had the issue where you weren't able to see this whole window, it was disappearing for you, that's why we add the main loop. All the main loop says is, don't make the window go away immediately. Keep the window there until the user closes out of it. So if I close out of it, there we go, the program ends. Awesome. So this is our first introduction into the tkinter module. Believe me, we're going to have a lot of fun with this. We'll learn a bunch of stuff, labels, menus, radio buttons in general, changing background color, stuff like that. And by the end of the section, the goal is you have understood how to create some nice looking GUIs in Python. See you in the next lecture. Alright, so in the last lecture we created a very basic, what would you say, tkinter window. There was nothing in it, nothing too fancy, it was just there. So the next thing I want to talk about is labels, adding text to your screen. For example, let's say I wanted to add a label onto that screen and say, welcome to our window, welcome to our app. How would I do that? Well, the first part of this would be initializing that label. Alright, to initialize that label, it works like any other Python variable. What you'd do is you'd say, let's call our label label, I guess. and set that equal to the function label. Okay, so we're saying label is equal to capital L label. Actually, you know what? Change the label to something else. Let's call it the label. Okay, so the label is equal to label, and then in brackets set which window is it part of? It's part of our root window. And then you want to set what's the text equal to. So like I said, it's going to be something simple. Going back over here, this is our Tkinter window. All right. So this is our Tkinter window. Very interesting. And if you just run this, let's go ahead, Command S or Control S, whatever you have for your machine. I have run this and my Python launcher will now appear. Right now you see nothing. All right. And trust me, don't worry. There's something wrong that we have done, and we'll get to that. But why are we seeing nothing? Why is this blank? We have initialized this variable, but nowhere are we saying add it into this window. So right now all we've done is we've initialized the variable. We've said it's part of the root window, but we've not say, hey, put it directly into that window. So this is where the pack, the pack function comes in. What you want to do is you want to say the label.pack. So to understand what's happening, whenever you add a widget, and trust me, in GUI programming, you'll always be adding widgets. You first create the widget, and then once you've created the widget, you have to pack it into the window. So basically, all packing does is it adds that widget onto your window screen. So again, it's a very interesting concept, .pack, and whenever we create a widget, we always want to pack it into our root or our window. So go ahead, save this again and hit F5. And now if you notice, as soon as our Python launcher runs, we now have this is our Tkinter window. Isn't that cool? So a very neat or nifty thing you can learn. So labels, all right? This is our introduction to labels in Tkinter. We created a very simple label and it looks pretty neat. Just for fun, let's go ahead and add one more. Command C these two lines. And let's just add, let's add 2 L's, so label, and this is our second sentence. Whoops, second sentence. All right, so we're packing the first label, we're packing the second label. Save this, F5, and now we're gonna notice that we have 2 sentences showing up on our Tkinter interface. Very interesting. So this is pretty cool. We have now added some neat labels onto our screen. You can use this in any way you want. Right now, if you notice, as we continue adding our widgets, they're being layered one after the other. So top, then underneath it, and so on. So as of right now, we haven't discussed placement, how to fit the widgets in your layout, creating a layout, stuff like that. So those are all things we need to discuss. Anyways, I'm going to end the lecture here. Very neat introduction into labels, and let's go ahead and in the next lecture talk about buttons. See you then. Alright, so in last lecture we talked about labels. We understood how the normal placement happens in Python or in Tkinter module, where as you continuously add widgets, the widgets will be placed one after the other. Now the next widget that I want to talk about is buttons. So buttons are obviously something you use every day, and buttons are actually quite neat. So you can perform functions with them, you can do stuff with them. So let's go ahead and learn how to create a very simple button. So I'm going to delete these labels and I'm going to create a variable called the button. All right, so very intriguing name, you might say. So I'm going to go ahead and use the button function this time. So the button function takes in a few parameters. The first parameter is, hey, which layout are you putting it in? Since we haven't discussed layouts, I'm going to go ahead and put none for this. Again, just leave none for now. We'll get to the next lecture or maybe in the following few lectures. Now, the next thing we want to talk about is the text. So what text do you want to have for the button? So every button might have a text like click me, go here, previous, next, stuff like that. So I'm just going to create a click me button. All right, the text will say click me. Let's go ahead and add an exclamation mark. And the last parameter it'll take is, do you want to change the text color? All right, so I'm going to change the text color, it's FG. Okay, so FG, and then you just set it to a color. I'm going to say blue. Okay, so we're changing the text color to blue. And now all I want to do is the button dot pack. Okay. Before we even run this, let's go ahead and add one more. Just for the fun of it, make things interesting. So the button is equal to button, none, text is hello. And then what I want to do is let's change my font or that front foreground color to be maybe red. Okay. And let's change the variable name to th button, the button. I'm not sure how you want to say it. So save this in F5, and when we F5 this and take a look, you'll notice one thing that is, what would you say, erroneous. So we get this click me with this hello, that's brilliant. However, what's wrong with the color, right? So this click me, this hello, I mean, these are fantastic looking buttons and they work, but we're not seeing any color. So this is one thing you might want to note about the Tkinter module with Macs, okay? If you're on a Windows machine right now and you ran this code, you probably must have seen this color appearing. You might have seen click me in red, hello in blue. However, if you're on a Mac, it just won't work. I'm not exactly sure why. I searched it up on a Stack Overflow question. It just doesn't work with the Mac. So you can't change the foreground, you can't change the background, etc. Now, we haven't talked about the background, but we'll get to that later on. However, again, colors don't work with the Mac. So if you're seeing a black click me and a black hello, don't freak out. Just chill and realize that you won't be getting any color anytime soon. Again, there are workarounds to this, importing the TTK module. If you want to go ahead and search on Stack Overflow how to get the desired colors showing up on your window, please do. Again, I'm not going to go that deep into a simple issue of colors, but yeah. So fantastic job. In this lecture, we learned about buttons, we learned how to initialize a button, and we learned about the foreground, how to set the text color of a button. Now in the next lecture, let's go ahead and learn about placement of these buttons, okay? So currently we have our buttons, click me and hello, one underneath the other. What if we could have it so that the buttons placement are maybe left, right, bottom, left, stuff like that. So see you in the next lecture. Alright, so in this lecture we're going to talk about a concept called frames, okay? And basically what a frame is, it's, let's say, a layout. And in this layout you can pull many different widgets, alright? So in this lecture we're going to be creating a top frame and a bottom frame, alright? And the way this will work is, I can't really speak that, so let me just go ahead and show you. So keep the buttons, alright? If you have deleted the buttons, make sure you get them back because we'll be requiring them. Now, the first command I want you to write is initialize the top frame. For example, I'm going to go ahead and open Paintbrush and show you how our app is going to look like. So currently, we have click me and hello, one after the other. What I want to do is, I want to create, suppose this is our Tkinter window. I want to have it so that one button is here, second button is here, third button is here, and fourth button is here. Alright, so instead of having it one after the other, down, 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 I want two on the left, two on the right. So this is the concept that we can achieve using our frames, using these layout concepts. So go ahead and initialize this top frame variable. And this is going to be equal to frame of root. So all this means is that, hey, we're initializing a layout, we're calling it top frame, and it's the frame, it's of the root app, it's of a root window. Alright, now what we want to do is go ahead and just pack this in, top frame dot pack. Alright, all packing does is, remember, it just adds it to our window. So now, if you run this program, I'm not going to do that, but if you run this program, there will be no change at all. But this is basically an invisible layout. You can't see it, you won't see it, but you can place objects inside of this. Alright, so we created a top frame. Let's go ahead and create a bottom frame. So I'm going to call this bot frame. Alright, and this is again going to be the exact same thing, frame root. And then go ahead and say bot frame dot pack, except in the pack statement, what I want you to do is specify side equal bottom. Alright, so I know what you're thinking, right? You're saying, Avi, you did top frame.pack up here, but you didn't specify the side equal to top. Why? Alright, so think of it like this. For example, let's say you have brick 1 and brick 2, okay? Or let's say you have a cup to the right, or just think of 2 bricks. Or, no, that's a bad example. Let me try to explain it like this. Suppose you have a watch and you have a microphone. Again, 2 completely random objects, but try to understand this here. If you say the mouse or the watch is to the right of the microphone, you automatically know that the microphone is on the left-hand side. So the same way, when we've specified the bottom frame is at the bottom, that means the top frame has to be at the top for this case. Again, if you add in more than 2 frames, then you might have to specify side is equal to top and so on. But since we are only specifying this as bottom, automatically Python will realize, hey, this needs to go to the top. Alright? Cool. So this is our top frame, this is our bottom frame. But right now you're going to notice that nothing's going to happen because if you remember in the button parameter, we're not specifying which layout we want it to go in. Okay? So let's go ahead and do that, but I think it's better if we first create our 4 buttons, not 2. So I'm going to remove this fellow button. I'm going to call this button 1. Okay? Button 1 is equal to that, button 1.pack, and button 1 is going to be part of our top frame. Okay? So again, this is the whole concept of layouts. You can put buttons and frames in these whole layouts to make them in the specific position you want. So button 2 and button 2. Okay, and again, this is going to be in the top frame. Now I'm just going to go ahead and copy this, Command C, Command V, or Control C, Control V. So button 3, go ahead, if you're on Windows, this should matter for you, change it to maybe purple, and make the top frame to bot frame. Alright, and last but not least, go to button or Command V and button 4, change the FG to maybe anything you want, maybe yellow. Again, it won't work for me, but if you're on a Windows machine, definitely do it because it'll help you out. And let's go ahead and do bot frame. Awesome. So we've now said that, hey, I want button 1 to be in the top frame, button 2 to be in the top frame, button 3 and 4 should be in the bottom frame. So far so good, it makes sense. Let's go ahead and run this and see what happens. So our program is now running, Python launcher has appeared, and if I open this, it gives me an error, button 4 is not defined. I might have made a typing mistake over here. Let's take a look. Button 4 is equal to that. Why is it giving me an error? Let's see. Bot frame, button 4.pack. Might just be interesting. Button 3 is equal to button, bot frame, text is equal to hello, FG purple. Oh, I see. So we are packing button 4 twice. Let's go ahead and change that. Button 3.pack, button 4.pack, save that, F5. And now it should work. Yay. So we get click me, hello, hello, hello. So you're probably wondering, well, why aren't these becoming side to side? Right now, if I expand this, you're going to notice we have the 2 hellos at the bottom and the click me and the hello at top. So it's working, all right? Our 2 buttons are now in the bottom frame and 2 buttons are in the top frame. And you can clearly see the difference in the gap over here. However, we want them to be side by side. Going back to our paintbrush image, remember 1, 2, 3, 4, side by side. So how do we achieve that in our layouts? So if you remember in the bot frame.pack, we used the concept of side equal to bottom. That specifically said, bro, I want you to make this object, this widget, be at the bottom. The exact same way what we can do is button 1.pack, side will be equal to left in all caps, and button 2, exact same thing, side is equal to left. And by doing so, button 1 will be initialized to the farthest left it can go, and then button 2 will go right next to it. Because it can't take up the space of button 1, it's going to go right next to button 2. Now, button 3 and button 4, exact same thing. Side is equal to left, and side is equal to left. All right, not F, left. So save this and F5, and now you'll finally notice, haha. So click me, hello, hello, hello. Fantastic. So we've now learned about layouts in Tkinter. We have learned how to create frames, how to put objects in frames, and then how to position those objects inside of the frame. So very interesting, and I'll see you in the next lecture. Alright, so in the last lecture we left off, we learned about layouts, okay? We had created two side-by-side buttons, very cool concept. And now I just want to briefly touch base on the concept of fill, okay? So I'm going to delete one button, okay? And I'm going to delete these frames and stuff, so bear with me here. Let me see what I'm doing. Let's actually, you know what, let's keep 4 buttons, alright? Button 4, button 3, button 2, button 1, except delete these frames. We no longer need these frames as of right now. So we've learned about frames, that was fantastic, and also make sure you change all the frame parameters to none. So none, 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 and none, alright? And then what I want you to do is, I want to talk about the concept of filling. So let's say you have a screen, okay, and this screen is resizable. So what I mean by resizable is right now in your video, you're seeing that the screen can now be resized from this big, to this big, and so on, right? I think I might have opened my system preferences, so let me just quickly close that. All right. So the whole concept of resizable is that your screen can go bigger and smaller and so on. However, these buttons don't. Right now, if we F5, so F5 save, okay, you're going to notice that our buttons stay put, okay? No matter how big the screen becomes, no matter how much resizing you do, the screen will, the buttons will remain the exact same size, exact same width, exact same height. So my Python launcher is taking some time to load. Bear with me here, but yes. So the whole concept of fill here is that, yay. So right now, if I expand, if I make these bigger, if I make them smaller, nothing happens. The buttons remain the same size they are. Now, what if you wanted so that as we increase the size, we want the width to also increase? As we resize, we want the height to increase or decrease. Well, this is where the fill concept comes in, all right? So let's go ahead and quickly discuss it. For the first button, we're not going to do anything. We're just going to keep that in the middle as an example button. All right. Now our second button, we've done button due to pack, side is equal to left, so it's left-sided. Let's make it fully fill X. Okay. So side is equal to left, fill is equal to X, and all fill equal to X means is, hey, I want you to completely fill the X coordinate. Okay, and if you ever use a Cartesian plane, you know X is the horizontal, Y is the vertical. So we're basically saying fill completely the horizontal width. All right. Now button 3, I'm gonna go ahead and say side is equal to right, and I'm gonna say fill will now be equal to Y. All right. So side is equal to right, fill is equal to Y, and if you've already guessed, fill equal to Y means vertically, I want you to fill this button the entire space of whatever the window is. And for our fourth button, we're just going to leave it just like that and back in the center, I guess. We're not going to even touch that for now. All right. So again, if you're on Windows, definitely try this out with backgrounds. Make sure you add some BG colors as well. Maybe a nice white or maybe yellow BG color for our first button and so on. Again, since I'm not on a Windows machine, you won't be able to see the results. I guess this is one of your incentives to buy a Windows machine if you ever wanted to. Otherwise, I'm sorry if you're on a Mac. Again, I'm facing the exact same difficulty, but if you're on a Windows, yay. So go ahead, save this, F5, and you're not going to notice via the fill function. Alright, so it gives me this error, name right is not defined. So that is because I have not made these in caps. My bad. Save this, F5. And now we should now see the build working. So I'm going to go ahead and expand this and voila. Pretty interesting, right? So let's take a look back at what the code we wrote. Button 2 was supposed to fill horizontally completely. What's happening? Doesn't look like it, right? The reason being is this. So our hello and our hello, these two buttons are, I guess what you'd say, colliding with each other. So since this button 2 and button 3 are on the same page, as you might say, they're not working. So what we have to do is we have to make one of their sides back normal. Alright, so no side for that guy. And by doing so, it'll now be centered. So technically, even with the fill is equal to X, the side shouldn't even matter because you're filling completely horizontally. So no matter left, center, or right, the whole area will be covered. So save this, F5, and now we should finally see our two buttons working. So take a look, guys. Pretty cool. Our hello button is now going horizontally the entire length of our screen, and our other hello button, this vertical one, is now increasing or decreasing with the vertical increase or decrease of our window. So again, very, very cool function that you can use with the fill. If you're trying to make your website or make your app, this sort of interactive fill, whereas the user minimizes or increases the size, you want the buttons to move along with it. Definitely check it out. Awesome job. So, alright, so fantastic job. We have now learned about this fill statement. We have realized how it can be used in the Tkinter module. And in the next lecture, Alright, so very nifty function. This fill function where horizontally and vertically both you can have our button, resize itself. And I guess I'll see you in the next lecture. Alright, so today we're going to be talking about the grid-based layout. Now, so far we've learned a pretty good introduction in Tkinter. We're learning about labels, we've learned about buttons, we've learned how to arrange our buttons, change the background, foreground, stuff like that, good stuff. And now I want to talk about the concept of grids, alright? So I'm sure many of you must have used Excel, right? Microsoft Office's major product. Almost everyone in the world uses it. So I've opened up an Excel document over here, and I just wanted to show you what this grid-based looks like, okay? So don't do this. You don't have to open up Excel if you have it. Just follow me over here. Now, the whole concept of grid-based is via rows and columns, alright? And you can put your widgets, which are created in our code, you can arrange those widgets into this grid-based layout. For example, if I said that I want my first widget to be in row 0 and column 0, I'll get it right over here. This would be widget 1. If I want my second widget to be right next to my widget 1, what can I say? I can say I want it to be in my first row and in my second column. So widget 2 would appear right over here. Now let's say I wanted to create a widget that was right under my widget 1. So the exact same concept happens over here, where we'd say row 2 and column 1 to get things started, and then widget 3 would happen or would appear right over here. So this grid-based layout actually, it saves more time, it looks more neat. Rather than putting those side is equal left, side top, side bottom. Again, that may get a bit confusing later on, but this grid-based layout is straightforward. Whatever code you're typing, it's straightforward and it'll appear in this Excel grid. Okay? So let's get started. Right now your code should look something like this. These three basic main lines that we've been using in every lecture so far. And I'm going to go ahead and create this exact same layout that I just talked about. So widget 1, widget 2, and widget 3. So let's go ahead and do that. Label 1 is equal to label, and it's part of root. And go ahead and say text is equal to label 1. Okay? Now label 2 is equal to label, root, text is equal to label 2. And for the last one, label 3 is equal to label, root, comma, text is equal to label 3. Awesome. Alright, so now what we have to do is we have to get this in the grid-based layout. So, you might be thinking, well, how's this going to work? Is it going to be like label 1 dot pack and then, you put in some grid function in it? No. pack will no longer be used, okay? And what I want you to think about right now is how grid works and how pack works. So pack and grid do the exact same function where they add your widget onto the Tkinter interface. However, using pack, you had to, pack worked on the basis of side equal to top, side equal to left, side equal to right. The grid function works on the basis of rows and columns, alright? So both do the same thing, except they work differently in the sense you can position objects differently using both functions. So they'll no longer be pack, instead we'll be calling label1.grid. And then inside of this grid function, we specify what's our row and what's our column. So going back to our Excel grid, right now it appears that our first widget should be in the 0th column and 0th row, or 0th row and 0th column. So let's go ahead and do that. Row will be equal to 0 and column will be equal to 1 or 0. So you're probably wondering, well, why not 1? And again, with most programming languages, it's the case where numbering always starts from 0. So your first object in an index or in a row or of some sort will always be in the 0th position. And then after that, 1, 2, 3, 4, and so on. So if you're using Excel to create your Python GUI, make sure you subtract 1 from whatever row number you have placed your objects in, okay? So label1.grid is row 0, column 0. Let's go ahead and add label2.grid. Going back to our Excel, we have it at the 0th row and the first column. So let's go ahead and do that. Row is equal to 0 and column is equal to 1, okay? And then label 3. So label3.grid, and I remember that it was below our label 1. So go ahead and set row equal to 1 and column equal to 0. Fantastic. So I'm going to go ahead and save this and run it. And now hopefully we should see our label 1, then label 2 right next to it, and then label 3 under label 1. Ta-da! So pretty cool, guys. Using our grid function, we have now added or created 3 labels. And we've set it so that label 1 is to the left of label 2 and label 3 is under label 1 using the whole concept of grid layout. So very interesting concept here, I guess, of the grid layout where you can position your objects using rows and columns. So very fun. If you have any questions, again, throughout the past few lectures about the grid concept, about layout, stuff like that, please feel free to leave a question and I'll get back to you as soon as I can. Now, in the next lecture, let's go ahead and discuss about entries. Alright, so we're now on to entries, okay? And this lecture is not going to go too deep into them. We're just going to create a simple entry box and a label to go with it, alright? So we'll be using our grid concept again, and let's get started. I'm going to go ahead and remove my label 1, or label 2 and label 3, and remove the grid functions for those. And what I'm going to do is, over here, I'm going to create an entry. So the whole concept of entry are text boxes where the user can enter data, they can enter maybe their name, their password, so on, and or maybe you want to convert some currency, convert some data. That's where you'd use an entry in your Python GUI. So label 1 is equal to label, root text should be equal to, for example, if we want the user's name, okay? So name, that looks good. And then what we want to do is, well, we want this. We want to add our entry. So I'm going to go ahead and call my entry, I guess, entry space, I don't know. And then what I want to do is create my entry. So creating the entry, just like with labels, just like with buttons, you're going to use the entry function. And then in it, just specify that it's part of our root app. So entry space is equal to entry root. This will now create that entry text box, and go ahead and add this entry to your Tkinter interface. So the way this is going to work, entry space dot grid, and then it's going to take in 2 parameters again, so row and column. Going back to our Excel, if we're taking a look over here, our entry will now replace our widget 2. So what was our widget 2? Row 0, column 1. Let's go ahead and add that. So my bad. Row equal to 0, column equal to 1, okay? Now, that's it. Command S, F5. And what do we have? We have Python launcher. Awesome. So again, a very, very cool build where we have a name, and in my text box, I can now write Avinash. I can write any data you want. So as you progress through this course, you'll learn how to use these entry boxes, how to get the value the user has entered, perform functions, and it's going to be a lot of fun. So awesome job. This was a lecture on entries, creating a very simple entry. And in the next lecture, I'll build on this app. Alright, so again, this is going to be a very short lecture, and I just want to talk about this object again. Entries are fantastic. We've talked about them, and actually don't delete that. Now, the next object I want to talk about that we can use with the Tkinter module is called a check button. So whenever you have this login or sign up form, you always note that they ask for your name, they ask for your password, and then normally in most websites, they're going to ask you, hey, do you want to be always logged in or keep yourself logged in? Something, oh, actually maybe remember your password. So something along those lines where they make sure that you always want to be logged in for a good amount of time until you delete your cookies, delete your passwords and stuff. However, we're going to be adding that check button onto our simple GUI. So right now we have names equal to Avinash, that looks fine, but I want to go ahead and add that, remember my name, okay? So the way this is going to work is I'm going to create a check button, okay? So I'm going to call my check button, I guess, C button, and then this is going to be equal to the check button formula. And by using this, you can create, not formula, I'm sorry, function. And by using this, you can create your very simple check buttons. So it's part of the root class or the root, app. And we have our text to be equal to, what do you want to call it? Let's say, remember name. Okay? So that's our C button. And last but not least, we just have to add this onto our interface. So C button.grid. Okay? And where do we want this to be? Well, let's take a look. We have this. Go back to our Excel. Widget 1 and widget 2, and that looks great. However, we want our C button to span both these columns, right? We want it to cover the entire window width, all right? So the way we can do this is by saying column span is equal to 2, all right? So that may be confusing, but go ahead and stick with me right now. So column span equal to 2. C button.grid, column span equal to 2. Alright, and what this will do is, whatever the width we've specified for column 1 and column 2, it's going to span both those columns, alright? So instead of spanning just one column, we've set it so that C button.grid will now span both the columns, alright? So save this, F5, and now if we take a look, we should hopefully see our C button being displayed. Hey, take a look at that. Isn't that cool? So we have our name, we have Avinash, and then we need to remember name, and we have a pretty nice checkbox. Awesome. So going back to our code, again, let's quickly cover what just happened. We used the check button function to create our C button, and then we added C button to our grid using the command column span equal to 2. Alright? So you're probably wondering, well, why didn't we specify the row or column? Well, with the grid function at least, suppose we have widgets in row 1 and row 2, and then we call the C button function. It'll automatically put our checkbox into row 3. So whatever the next free row is, it's going to put it there. Alright? So awesome job. And in the next lecture, let's go ahead and finish up this quick sign up form by adding a password field to it. Alright? See you then. Alright, so we're almost done with our very simple, sign-in form, I guess you'd say. We have our name and we have our remember name. That looks good. So I'm pretty sure we don't want the user to remember their name. That's something they're obviously going to remember, except we want to remember their password instead. Alright, so let's go ahead and do that. I'm going to copy, or actually don't copy, just go ahead and create a new label. Label 2 is equal to label, and this will store, again, the password. So this is a password indicator, password, and then entry space, or wait one sec, never mind. Go ahead and add label 2.grid into our interface, and row should be equal to 1 and column should be equal to 0. Okay, so again, updating our Excel, we have name text box, we have password, and we have password text box, and then we have one which will span both of these, which is our check button. All right, so again, a very interesting GUI for now, at least if it's a very simple one. And let's go ahead and finish this up. So we have now set the label. Go ahead and create one more entry space for this, entry space 2, I guess you call it, and set this equal to entry of root again, same concept as before, and then add this entry space to our GUI. So dot grid row is equal to, let's think about this, row will now be equal to 1 because we're now on the second object, and column will be equal to 1 as well. And then we have our C button. So awesome job, everything looks good. Command S, Control S, F5, and now we'll have a very simple sign-on form. So we have name, Avinash, awesome. We have password, I'll put some random Red Sox 88. And then remember name. So, whoops, go ahead, change this back to remember password. Save this, F5, and now our build is finally complete. So it's a very basic sign-on form. It doesn't have any functionality yet, but we learned a lot. We learned how to use some of the new widgets. We learned about entries. We learned about check buttons. We learned quite a lot. And to finish things off, I'm sorry, I can't speak today. Let's take a look at what's happening over here. So right now, our labels, okay, our labels are right now centered, and that looks okay. That doesn't look too professional. So what if there was a way in which we can make our labels both right aligned, all right? So that they're right next to our text box, and it makes things a little bit more professional. So the way we can do that is using the function called sticky. And this goes directly into the grid parameter. So row 1, column 0, and then sticky will now be equal to E. And all this means is, hey, I want you to right align my content. Okay? Do the exact same thing for label 1, comma sticky, set this equal to E, Command S, F5, and now we'll have 2 right aligned labels. All right? Take a look at that. Pretty neat, right? So now it's a little bit more professional, maybe a little more nicer, but awesome job, guys, and I'll see you in the next lecture. All right, so guys, congrats. I mean, if you're already this far and you're learning how to make these awesome GUIs, dude, I mean, I'm super proud of you guys. Most people will buy the course, they won't go through any of it, and I mean, to see that you guys are listening to this video and learning about GUI and stuff, awesome job, okay? So we're now like at that stage where, I mean, we've created some pretty nice GUIs, but they're not doing anything, right? We want something to happen. We want, actions to be performed. We have buttons, right? What is the whole purpose of buttons? To do an action. So how does that work in our Tkinter module? How do these functions get performed? How does this work? Well, that's what we're going to discuss in this lecture. So currently right now, I'm just going to go ahead and delete everything that we don't need. So that's pretty much all of our user sign-on module or code. And now what I want to do is talk about, well, how is this going to work? So another parameter of the button, okay? So let's go ahead, create a button 1, set this equal to button, and go ahead, make it root, and just say text as click me. Text is equal to click me, okay? And you're gonna notice that right now there's nowhere saying that I want to perform a function, I want to perform a command. So there is one more, I'm not sure how many parameters there are to the button class, but another parameter is the function or the command parameter. And all the command parameter says, hey, do you want me to perform a function every single time this button is clicked? So obviously our answer is yes. I mean, yeah, that's the whole purpose of this lecture, to perform a function via our button. So before we even get started writing that function or naming it over here, let's go ahead and create it. And it's going to be def. What am I creating? Well, I just want to create a simple, just print out my name. Okay, so print name. Okay, def print name takes in no parameters. And then what I want, well, I want it to just say print hello there, Avinash. All right, so there we go. Def print name, print hello there, Avinash. And now in our command parameter, just go ahead and say command is equal to print name. Okay, so again, it's a very basic command. It's a very basic function by itself. But I just want to show you how you can make things work, how you can perform a function via a button. So go ahead, command S F5 and run this. And now hopefully we should have something pop up. All right, let's take a look. No, there's not. And obviously you can see why we haven't packed our button onto our screen. So button1.pack, again, that was my mistake. Command S F5, and now we should see things happening. So you won't be able to see my my shell, so let me just minimize that for you over here. We have my click me button. Fingers crossed, guys. Take a look. Pretty neat, huh? Hello there, Avinash. Yeah, I'm liking it too. So awesome job. This lecture was just a very, very simple introduction to functions being performed in buttons. All right, and there's one more method to do this. I'm going to talk about it in the next lecture, but there's another method to do this, and that method is actually used quite heavily in gaming with this module. Okay, so when we create games and stuff, we'll be using the second method more often, but I'm just going to go ahead and show you how it works. Alright, so this concept that we're going to talk about today is heavily used in the games that we're going to create. So Bounce, Pong, games like that. This is where the concept of binding comes in. Alright, so I'm going to modify this code, okay, and trust me over here, I know what I'm doing. And once I modify the code, I'll quickly show you why I did so and what does it do. So we right now have button1 is equal to button, root text is equal to click me. I'm going to delete this command. All right, we no longer need this command for this new version. And in our def print name, I want you to go ahead and type in the parameter event. All right, so button1 is equal to button, root comma text is equal to click me, and def print name is now has a parameter called event. Okay, now the last thing is I want you to add this function button1.bind. And then in the bind function, write the following statement. In quotation marks, button1. Sorry, not in quotation marks, actually in alligator mouths. So quotation, alligator mouth, button1. And then we have over here, print name. Alright, so again, this code does look a little bit confusing, but let me explain what's happening. So we removed our command parameter from our button. All right. So right now, if you click the button, we haven't specified anywhere that we want this function to be performed. Now, this whole concept of binding comes from events. All right. So when a key is pressed, if I hit the arrow key, that is an event. If I hit the mouse key, it's an event. If I hit the spacebar key to make a character jump, it's an event. All right. And all these events you can track, okay? You can track these events, what's happening. For example, in our games that we're going to create, if the user hits the up arrow key, we want our guy to move up. So how do we know what's happening? Well, this is where the bind function comes in. And the bind function takes 3 or 4 parameters, but here are 2. The first parameter is, what should we be looking for, all right? What are we binding? And here we're saying if our left mouse is clicked, that left mouse, this clicking function, if the left button of our mouse is clicked, then we want to perform the function print name. So think of it as we have binded the left click action to the print name function. All right, left click action to the print name function. All right, it rhymes, but it makes sense. All right. So button1.bind takes in 2 parameters, where the first parameter is what event do you want to be performed. For example, we could do the exact same thing with our arrow keys. There is a specific key which tracks to see if the up arrow key, down arrow key, right arrow key is pressed, and then we can go ahead and perform print name if so. All right. Again, we'll talk about this more in the gaming section. Right now, I just wanted to show you how it works. And we put the event parameter in here so that the bind function will work, because the print name will only work if there is an event happening. So Command S, F5, let's go ahead and run this. And now if you notice, over here, let me just expand this a bit. Click me, click me, click me. Pretty cool, right? So every time I click on this button, this bind function occurs. Button 1 gets triggered because we have now left clicked our mouse. Print name occurs, and hello there, Avinash happens. So if you were able to see my shell, I'm not sure if you were. Let me go ahead and bring that up. Yes, you were. Awesome. So you can go ahead and try out. There is a list of bind keys. Again, you can find out what are they for the arrow keys, for the WASD, spacebar, etc., etc. Go ahead, play around with the bind function, and I'll see you in the next lecture. Alright, so in the last lecture we left off where we had, whoops, over here. We had left off where we had talked about binding actions to functions, okay? I thought the concept is very cool, and I want to build on that a little bit more in this lecture. So we're going to talk about a multitude of different actions that you can perform. Basically, our left click, our right click, our mouse scroll, and then are the 4 arrow keys, alright? So 7 different functions, and each function will produce a different result. So it's going to be a lot of fun, and I just want to show you how this binding process happens. So we have our root is equal to tk, and I'm going to go ahead and create these 7 functions. So our first function is our left click. Okay, there we go, and just print out left. Okay, something simple. Now our second, def right click, pass an event, and then print out right. All right. Then our third is def scroll, I guess, because of the mouse scroll event, and you can say print scroll. And then I'll just do left and right for now. I'm not going to take up too much of your time. So left key and right key. Def left key, or left arrow key is fine. It takes in the parameter event again and print out, let's print out left key pressed. Okay. And one more. Def right key, takes in the parameter event, and it prints out right key pressed. All right, so this is gonna be a lot of fun. All right, looks good. So we now have this stuff. Go ahead and remove this. Okay, we don't need our buttons right now. What I want you to do is I want to create or increase our interface size. Okay, and the way we can do that is calling our geometry function. So if you say root.geometry and then specify what do you want it to be, you can change your Tkinter window height and width. So if I want my window to be 500 by 500, I do something like this, where you're using the X to signify times. So root.geometry 500 by 500 will set our window size to be 500 pixels by 500 pixels. All right. And last but not least, I'm going to go ahead and add all of these or bind all of these functions to our root. So root.bind. So let's do the first one, which is going to be, I believe it's click. No, I'm wrong here. Mouse click events. It's going to be left click. So first one is our left click, and go ahead and pass in button 1. Okay, capital B over there. Okay. Now, after that, we want to pass in which function we want to call, and that's going to be our left click. Cool. Our second is root.bind, and I'm just going to go ahead and copy this. I'm not going to write this over and over again. You can skip ahead if you want, if you know what's happening, but the commands for the left and the right are left and right. Haha. So button 2 2 is our right click. Button 3 is scroll. This is going to be left. This is going to be right. Let me make sure that those are correct, left and right. Yes, they are. So left and right look good, except what you want to do is you want to call the functions now as well. So left click over here, right click when button 2 is pressed, scroll when our scroll is scrolled, I guess. I'm not sure what to say there. Left key when we have our left arrow pressed, and right key when we have our right arrow passed or pressed. So again, a lot of code, okay? You might have been lost over there, but just take a look, make sure you have everything. Left click, right click, scroll, left key, right key. Root.geometry, we're setting the window's height, and then we're binding all of them to our root. Command S, F5, and we should now see some progress. So my Python launcher has now appeared. Let's take a look. Yay! So first thing you have to notice is that our window size is now 500 by 500. So that's exactly what we wanted, and that's great. So I'm going to go ahead and minimize this because you won't be able to see what's happening on my screen. And I'm putting my shell a bit to the left. So you can't see what I'm doing with my mouse and my keyboard, but I'll be saying as I go. So this is my left click. Awesome. This is my right click. Okay. This is my scroll. Actually, for the scroll, you actually have to hit the scroll button. So scroll, that's pretty cool. Now I'm going to hit the left arrow key. Awesome. And the right arrow key. Fantastic. So in this lecture, we learned how we can bind a multitude of what would you say? A multitude of actions to one widget. All right. So we binded all these different actions, you know, left click, left arrow, right arrow, all to our main root, okay? And it's not just root. You can bind it to any widget you want. This could have been a label. This could have been a button. Who knows? Except the main concept I'm trying to get at here is that you can bind as many functions as you want to a widget of any sorts, all right? So awesome job. We learned left key, right key, and are using all 3 buttons of our mouse. That was a lot of fun, and I'll see you in the next lecture. Alright, so today we're going to be talking about probably a concept you're wondering. And it's basically getting data from our entries, alright? So let me just quickly create my Tkinter application. As you can see, it was blank, and now I'm adding some data into it. So let me just get our 3 basic entities into my code. Alright, awesome. So we're going to be creating a very simple calculator app, okay? Actually over here, let me just say from Tkinter import everything, okay? So the way this app is going to work is the user enters an expression, then we get whatever the user enters, we evaluate it, and then we push it back out and update a label, all right? So this is the way it's going to work. What I want to do is, let's quickly talk about the basic principle here. We learned about inbuilt functions, or if you haven't, don't worry. Inbuilt functions here, the one we want to use is the evaluate function. So the evaluate function takes in any expression and it evaluates it, so we'll be using that. Let's get started. First thing first, let's go ahead and create our entry. So I'm going to call my entry E, so E is equal to entry. And in my entry, I'm just going to put in my root. So nothing too bizarre. And the way this is going to work is the user presses the enter key. And as soon as the enter key is pressed, a function is triggered. And whatever expression the user's entered will be evaluated. So if you remember in the previous lecture, we talked about binding. So just like there's a left and right arrow key, the left and right clicks, there's also one for the enter key. So go ahead and add that bind, e.bind. And the 2 parameters, the first one is going to be return. So return, if you're on a Mac, stands for enter. Otherwise, you normally have an enter key on a Windows keyboard. So the function you want to call, let's go ahead and call that evaluate. Okay. We haven't created an evaluate function, so let's go ahead and do that. Def evaluate. And all this evaluate function is going to do is, hey, it's going to update a label that we haven't even created yet. So think of it like this. Whenever we hit the enter key, the first thing that's gonna happen is we're gonna get whatever E holds. All right. So whatever our entry holds, whatever value it holds, we're gonna get that data. So to do that, let's go ahead and create a variable. I'm gonna call this data and set that equal to e.get. All right. So this e.get function basically returns any data or all the data that has been entered into your entry object. All right. So data will now hold our expression, and all we have to do now is update our label with the new what would you say? We want to update our label with the new value. So whatever the expression evaluates to, we want to update it with that. So let's go ahead and create our label over here. I'm going to call this answer. So ans is going to be equal to label. Again, nothing too fancy over here. So ans is equal to label root, and all we have to do now is just pack this in. Okay. Go ahead and for the E, make sure you pack this in as well. Cool. So now that we've created our variable, let's go ahead and set the text. So whenever you have already created a variable and from someplace else you're setting the text, the way you do that is using the configure function. So what you can say is ans.configure, okay, and text will now be equal to what do we want it to be? Answer, and then you can do something along the lines of plus str eval data. Okay, so that looks good, and go ahead, save this. Everything looks fine over here. Command S F5. Let's take a look. All right, so we have in our shell an error that says evaluate is not defined. Obviously, evaluate is not defined because we spelled it wrong. So evaluate. Command S F5. Let's do this one more time. Restart, as you can see, looks good. Let's get the whole restart over there, and I'm gonna open this up. Fantastic. So we have our small text entry, and we have a label at the bottom, as you can see. That's why there's a gap. Let's go ahead and add an expression, 15 plus 20, or 15 plus 20, and it gives us an error. It says over here, evaluate takes 0 positional arguments, but 1 was given. So here's our first, what would you say, maybe bug, okay? Taking a look back at our shell, where's our shell? Python shell. It says over here, evaluate takes 0 positional arguments, but 1 was given, and let's take a look why this is happening. So remember, with any e.bind, we have to put the event parameter inside of the function. So that was my bad. I accidentally forgot about that. Go ahead. Let's run this again. And now hopefully we should get a running build. So 15 plus 20. Take a look. Pretty neat, right? So let's quickly cover what just happened. All right. If you ever have an entry, to get that entry's value, whatever value it has currently, you call the function e.get. All right. Now for this simple calculator, all we were doing is whatever expression the user has entered, we're storing that into a variable called data, and then we're evaluating data, converting it into a string, and then configuring our label's text value to become the new data or the new answer. So let's go ahead and try another one. I'm going to say 35 into 7, 245, pretty sweet. One last one, 90 divided by 10, 9. So again, a very, very simple but fun to use Python calculator. Now, definitely let's go ahead and add a label up top. And all this label is going to say, enter your expression. So I don't like leaving that blank space. I'm going to say label 1 is equal to label, part of root, and text is equal to enter your expression. Okay. And then what I want to do is, that looks good, and label 1.pack. Okay, Command S F5, and now it'll look a little bit more neater, right? So you actually have a sense of what's happening. We have enter your expression, that gives us a hint that, hey, this is a calculator app. Let's go ahead and enter some stuff. So I'm going to do one more, 42 into 5, plus 3. And if you notice over here, the operation of PEMDAS does occur. So instead of doing 5 plus 3 first and then doing 8 into 42, it knew that multiplication comes first, did 42 into 5 first, and then added the 3. So again, guys, a very interesting application. You can definitely build on this. Go ahead, play around with it. But the basic goal of this lecture was to understand how to get this entry's value. All right, so once the user enters the value and he hits enter or some button, how to get that entry's value. So maybe as a challenge in one of the future lectures, we can go ahead and actually create a fully GUI-based calculator, actually having that 1, 2, 3, 4, 5, 6 buttons, and also using the plus, minus, multiply, and divide signs. I mean, it's something to think about. Maybe at the end of this Tkinter section, we can definitely create a very cool looking calculator app. See you in the next lecture. Alright, so we've been covering a lot with the Tkinter module so far. I mean, we've talked about buttons, we talked about labels, getting values from the user, about the fill, about the grid, layouts of different objects, stuff like that. So I think by now you're slowly understanding how powerful Tkinter is and how many different things you can create with such an amazing module. Alright? So the next widget that I want to talk about is a message box. So many times when you're on your browser and you might click some unknown link and then they'll say you won $1,000, you won 25 free gift cards. I mean, I'm pretty sure most of you must have seen those type of links. And how does it work? Well, the website posts an alert, right? So if you've ever programmed in JavaScript, you know what an alert is. Alerts are basically the concept of a dialog box appears on your screen and you have to say yes or no or okay or something like that. So we're going to learn how to create a dialog box or a message box in Python. So the concept is quite simple. What we have to do is basically it's one line. Tkinter, that calls the module again, message box, so dot message box, and then you say what type of message box do you want. So since we're creating a basic message box, it's gonna be show info. So go down or more down actually, show info. So as you can see, there's all sorts of different, what would you say, different message box. You can ask a question, you can ask yes or no. You can show an error, stuff like that. So we're going to be just saying .show info. And the show info just takes in one parameter. What are you posting? So I'm going to say, did you know that the world just blew up? Something random, something funny. You can do whatever you want. And the core concept here is I just want to show you how this will work. So F5, Command S, F5, and now if we run this, we will get, wait for it. Alright, it's going to come any moment now. Come on, Python. Alright, so Tkinter is not defined. The reason why this is happening is sometimes in cases like these, you especially have to import the object into your program. So right now our code up top says from Tkinter import everything. However, sometimes it doesn't work. Sometimes you have to individually import the special things you're using. In this case, we're using a message box. So what we have to do is import Tkinter.messageBox. All right. Now, if you're wondering why I'm doing this, if you didn't see the error basically says name Tkinter not defined. So Command S, F5, and this should hopefully work. Take a look. So this is our message box and there's nothing in it. Wow. So I sort of messed up over here. Hit OK and close this out. So my parameters actually got a bit messed up. And what you actually have to do is specify two things. So the first parameter is, what is it called? So you can just say window title for now. And comma, did you know the world just blew up? I'm dead serious, guys. So take a look. Once we specify the second parameter, right, or actually the first parameter in this case that we said you added a title, now we have, did you know that the world just blew up. So pretty cool. I mean, you can now create those sort of alerts that you might have learned in HTML and stuff in Python. So hit OK, and let's go ahead and talk about one more type of alert. This is great and all, but let's go ahead and discuss one more. So the next one is going to be an ask question one. So many times you're going to ask yourself, well, what if I want to create like a questionnaire? So are you older than 18? If the user hits yes, then you give permission for something. If the user hits no, then you don't give them permission. Stuff like that. So let's go ahead and understand how that works. Write this statement. Answer is going to be equal to tkinter.messagebox. And if you're one step ahead of me, or if you remember what we had just seen, it's going to be ask question. Okay? And this ask question, basically it's yes or no. So go ahead and just give it a title, maybe question 1, maybe whatever you want. And my question is, are you human? Okay? That's my question. Again, it's a very simple question. And then what I can say is, if answer is equal to maybe yes, all right? So if this guy is saying, yeah, I'm human, don't worry, bro. Then what we can say is, let's go ahead and print out another message. I'm going to go ahead and copy this. Command C, Command V, change this to congrats, and change this to thank God. It's good to know another human is out there. Okay, again, something random. I mean, don't copy me. It's just something I like to do. So if answer is equal to yes, that's that. Else, or elif, whatever you want to do, just do another if statement. If answer is equal to no, right, then we're going to say tkinter.messagebox.showInfo alien. You are 100% confirmed. You are, how would you phrase this? You are 100% confirmed alien. I'm not sure that's the correct English, but that works for now. So Command S, F5, and let's take a look. So basically we're asking the guy, are you human? If he says yes, we give another message saying thank God. And if he says no, then we say you're 100% confirmed alien. So did you know that the world just blew up? Okay, we don't really care. And now it asks me this. So as you can see, the icon has now changed. It's now changed to maybe an alert or a question. It's asking me, are you human? So let's say, no, I'm not human. What does it do? It looks like it didn't work. Wah, 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 wah. Let's go ahead and try the yes. Let's see if yes works. Probably it won't, but let's go ahead and try it. Are you human? Yes. Nope. So the error that's running into is that it's not going to be capital yes. It's going to be lowercase yes. So I know it's a bit stupid, but that's the way it works. Let's go ahead and try it out. Hopefully this will fix the issue now. So basically we just changed answer equal to yes and answer equal to lowercase no. So world just blew up. Are you human? No. Voila. You are 100% confirmed alien. Pretty cool, huh? So this was the whole concept of message box, where we're just talking about, hey, this is an alert. This is how to show an alert. This is how to call an action if the user hits yes or if the user hits no. So awesome job, guys, and I'll see you in the next lecture. Alright, so today's going to be a fantastic lecture on the concept of menus. So I'm in a Mac right now, alright, and every Mac user knows what a menu is. So a menu is basically this top bar that you see. You have options like file, edit, format, stuff like that. And the basic goal of today is to understand how to create this drop-down menu for our Python GUI, okay? So if you're in a Windows, you probably know what a drop-down is. If you don't worry, it's nothing big. It's basically a menu option that you select to perform some function, alright? So this is how it's going to work. First thing first, we need to initialize our menu. The way you can do that, menu is equal to menu, or actually what I'm going to call this the main menu. So when we initialize this main menu, you're going to notice that the main menu is actually this. So this white bar up top is what we're going to call the main menu. So main menu is going to be equal to menu, and that's a menu function. And we're just going to pass in what app it's about, which is going to be the root app. So we've now created our main menu, which is good. Now, the next thing you want is to create one of these. So one of this file, this edit, this format, we want to create this sub menu, okay? So this is sub menu 1, sub menu 2, sub menu 3. The main menu is the accumulation of all these sub menus, okay? So this is a concept I want you to understand. The menu is this whole top bar. The sub menus are gonna be this file, edit, format, etc. So let's go ahead and create our first sub menu. So sub menu is equal to menu function again, except instead of root, it's part of our main menu. So by specifying this, we say that, hey, make sure you add the sub menu as part of our white strip. Now, there's one thing I missed actually over here. Once you've initialized the main menu, you actually have to set this menu for our app. So what we have to do is we have to say root.configure, and then in our configure option, you say menu is equal to main menu. So the root window or a TK window always has the option of adding a menu, okay? And right now we have to specify that, hey, the menu that we're creating, the main menu, should be set as the menu of our root window, all right? So submenu is equal to menu, make menu, and to get this drop down, okay? Right now it looks fantastic. We're only gonna see file. We also want this drop down. So this is the concept of add cascade, okay? So if we call main menu dot add cascade, all it's gonna do is it's gonna add that drop down for us. So it's gonna ask you, hey, what do you want to call this drop down? So we want to call it, let's say, file. So let's quickly mimic whatever Apple has done for us. So label this file, and it's gonna ask you what sub menu do you want to add. So the sub menu is gonna be, well, our sub menu. Quite simple. So save this, F5, and then let's take a look at what's created. All right, so it looks like my shell has just run. Python launcher coming. I'm gonna go ahead and put the shell outside. So our TK window has come. Go ahead and select this, and immediately you notice up top over here, you have Python, and then you have file. Pretty neat, huh? So if you don't add the sub menu, if you remove these two lines, you're gonna notice file doesn't appear. If you go back to this thing and select, this file won't appear. So pretty cool. We have now added our first sub menu. And what we wanna do now is add a drop down. We wanna drop down like this. So how do we do that? Well, let's go ahead and add the concept of commands, okay? So the way this is gonna work is, well, sub menu. So go ahead and type with me, submenu dot add command. Add command. And let's go ahead and give it a label. So this label is gonna be, let's just say random func, okay? And it's gonna ask for a function. So what function do you want performed when this option is selected in your menu? So we don't have a function yet. Go back to your root.tk, under it, create def random, okay? And all this random function is gonna do is it's going to print out, print this is a statement. So something straightforward, and we'll be adding this function to all of our add commands. So we're adding this command to our sub menu, and go ahead and add command is equal to random. All right, so pretty straightforward. So we've added this command, and that looks good. Go ahead and F5, and let's see if there's any changes to our TK window. So my Python launcher has now appeared. Select this, file, random func. Pretty cool, right? So as you can see in my shell, this is a statement has now appeared. Random func, this is a statement has appeared again. So this is the whole concept of main menus, sub menus and stuff. Let's go ahead and add a few more so that we slowly get the hang of what's going on. Sub menu, let's go ahead and let's say submenu dot add command. The command for this, let's do new file. Okay, so label is equal to new file, command is equal to random, command S, F5, and we'll now notice that we have two functions. So again, pretty neat. Hit the TK, file, random func, new file, both do the same thing. So let's go ahead and quickly talk about some other things that you can add to menus. There's not much to it, and again, I'm not going to go too deep. One more thing you can add is something called a separator. So submenu.add separator will basically add that dashed line to separate 2 or 3 commands from the top to 2 and 3 commands from the bottom. You'll see what I mean soon enough. So I'm adding the separator, and let's go ahead and add one more command. So label will be supercalifragilistic. I'm not sure I spelled that right. Command random. So F5 this, and now you're gonna notice that we have three. Oh, whoops! What happened over here? Let's take a look. Submenu.add command label is equal to supercalifragilistic command random. Submenu.add separator. However, in our TK window, we're only seeing random func and new file. Interesting. So let's go back over here. Let me try adding this. I know what the issue is actually. So I'm not sure if it's an Indian thing or something, but I picked up spelling separator to be S-E-P-E when it's actually supposed to be S-E-P-A. Command S, F5. I'm sorry about that, guys. Quick spelling mistake. Let's take a look. Select this TK, file, random file, new file, this dash line, supercalifragilistic. Awesome, guys. This whole lecture, I just want to show you how these drop-down menus work. As you can see, we've learned how to create a menu, a submenu, and then adding commands to that submenu. As you can see, we have random file, new file. We learned how to add maybe a separating line, and then we added one more command. So awesome job, guys, and I'll see you in the next lecture. We've covered a lot in the Tkinter module, and today I just want to finish things up. So we still have a little bit to go talking about the canvas, creating shapes, objects, stuff like that. But for the Tkinter module at least, let's go ahead and finish this off with a bang. So if you remember a few lectures ago, I was talking about a calculator, how we can create a completely redesigned calculator app, creating all the buttons, the 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, plus, minus, divide, multiply, and equal to. Alright? So it's going to have all those buttons, a label on top, stuff like that. And basically, we're going to create the whole calculator UI and make it work. So let's get started. First thing first, go ahead and get those first 2 or 3 main lines over there. I believe I'm missing 2. One of them was t is equal to tk, and then the other was t.main loop. All right. So these are our 3. I'm sorry, not t. We did root. I'm sorry. Whoops. Sorry about that, guys. Root is equal to 2tk and root.main loop. All right. These were our 3 main statements. So let's get started. First thing first, think about what's going to happen. I'm going to open Paintbrush and show you how our layout's going to look like. So over here, I'm just going to do 800 by 600. That's our normal size. 800 by 600. So over here, you can see part of the screen at least. If you take this to be our screen, then the way it's going to be is our label up top. 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 at the bottom. Whoops. Equal to over here. So this is our equal sign. This is plus. This is minus, and multiply. Whoops. Multiply and divide. All right. So this is how our quick calculator layout is going to look like. All right. So label, our 10 buttons, and then our 5 calculation buttons. So pretty cool. And let's get started. So first thing first, let's get our label out there. Again, pretty simple. We've talked about this before. I'm gonna call this let's call this calculation, because that's where the basic calculation is gonna happen. Again, this is equal to label root, and what I want to do is actually create a variable and set this equal to. I'm gonna call this variable as equation. Alright, and I'll show you what I'm doing, don't worry. Equation is equal to string bar. Alright. You're probably wondering, well, what is a string bar? What does it do? Well, if you want your label's text to update, alright, you don't want to recreate the variable each time. You want to update the text of your label. What you can do is you can create a string var. And then every time you change that string var's text, your label's text will also update. So it's a very neat, what would you say? It's a neat function of Python, I guess. I'm going to quickly save this document. So over here, it's asking me to save. So let me go ahead and save this as calculator tkinter. Okay. So we have label and then root. So what we want to do is we want to say text is equal to equation. All right. So instead of setting it to our normal text that we used to do, we're setting root comma text is equal to equation. And then all this does is, hey, whenever the equation string var updates with any new text, what do we want to do? We want to update our calculation label as well. So to set the string var, what we can do is we can call a function equation dot set, and then you can specify, hey, what text you want to set. So let's quickly just try this out. Equation dot set, I'm going to set it as 23 plus 54 for now. Again, something simple. And let's go ahead and add calculation is equal to, dot grid. So let's go ahead and specify, hey, where do you want to put this? So for the grid, for this actually, we're going to be using the column span that we talked about a few lectures ago with the checkbox. So calculation.grid, column span, and think about it. So going back to our paintbrush, how many columns is going to span? 1, 2, 3, 4. So 4 columns, all right? Root.main loop, column span is equal to 4. So save this, run. F5. And let's take a look. Hopefully now we should see something. Okay, it's giving me an error. TK is not defined. Probably because I did not use my correct statement over here. From tkinter import everything. So, alright, one last thing before we run it actually, and this is quite key. I made a small mistake over here. When we're saying calculation is equal to label and then root comma text is equal to equation, instead of saying text, we're actually supposed to say text variable. And all this specifies is, hey, this is a variable that we're setting the text to, so whenever this variable updates, etc., update the text. So go ahead, save this, F5, and now we should see 23 plus 54. Pretty neat, right? So this exact same concept we're going to be using with our calculator app, all right? So whenever we're creating that the label part, so if the user hits the 1, we want the label to update showing a 1. If the user hits a 2 next, we want to show 1, 2. Stuff like that. So awesome job. In this lecture, I just talked about like how this app is going to work. We learned about the text variable, how to update the label's text using a string var. And in the next lecture, let's go ahead and get our buttons created. See you then. Alright, so today we're talking about adding those buttons into our calculator GUI. Alright, so last lecture we talked about that string var, we learned how to update the label, and in this lecture let's go ahead and create our 12, 13 or so buttons. So remember, the way this is going to work is each button will have root, text, a function, except we're going to be calling the same function each time for our 0 to 9 buttons, alright? So by 0 to 9, I mean from button 0, button 1, button 2, all the way to button 9, alright? And the way this function is going to work is we pass in a parameter what number, or what number is the user pressing, and then based on that, the function takes in the number and updates the label with that number. So let's go ahead and first create that function. That function is going to be something along the lines of, let's call it btn press, and it takes in the parameter num. Alright, so we got def button press num, and basically the way this is going to work is we're going to create a variable. Okay, this variable will hold the string of our equation. Okay, every time button pressed is called, this variable that we've created will update with the new thing that's being pressed, whether it be num, whether it be the plus, minus, whatever. And after it's been updated, we're going to reset our equation, which is a string var, to the new value. So let's go ahead and do that. I'm going to create this variable. I'm going to call it equa, I guess, or I'm going to call this, equa. Alright, equa is equal to, and I'm going to put it 0 for now. Alright, equa is not equal to anything. So we're saying def button press. Alright, and remember, we talked about global and local variables a few lectures ago, actually, in the basics. And to actually call a global variable over here, what we have to do is we have to first specify global equal. Because we're changing the variable of equal, or changing the value of equal, we have to specify that, hey, this is a global variable. Make sure you're getting hold of this variable. As soon as you call global equal, what we have to do now is say equal is equal to equal plus str of num. Did you get that? Well, take a look. Whatever equal will hold, that's fine. All we have to do is add the new number to the string of equal. So we're keeping whatever equal had, and we're adding the string version of the new number. All right. So equal that, and then all we have to do is say equation.set equal. All right. So pretty nifty feature over here. Go ahead and save this. Now that we've gotten our button press function figured out, let's go ahead and start out with let's do 3 buttons. All right. So button 0, set this equal to button, and root text is equal to 0. And over here, this is where we're going to change things up a bit. All right. And we're going to be talking about the lambda function. So basically, the lambda function is an anonymous function. All right. And the way lambda works is you don't have to create that function anywhere else. It can be a function that you create instantaneously. So what I want you to do is text is equal to 0, command is equal to lambda action, or well, basically our function name, which is button press, and then what are we passing in? We're passing in 0. Okay, so save this, and let's take a look at what lambda is doing. All right, so I'm gonna read basically what lambda does. Lambda works just like a normal function. All right, except the lambda does not need a return statement. It always contains an expression which is returned, and you can put a lambda definition anywhere a function is expected. All right, so it's basically known as the anonymous function. Don't worry about it. It enables us to pass in parameters for our button field. So leave lambda at that. If you have any questions on lambda, you can ask them in discussions forum. Anyways, let's move on. So we've created button 0. I'm going to go ahead and create button 1 and button 2 as well. So button 1, button 2, and over here change our text to 1 and 2 as well, and change these to 1 and 2 as well. Now last but not least, go ahead and add them to the grid. So button 0 dot grid. Again, we've done this before. What's the row equal to? Well, since our equation is now on the first row, we have to, on the 0th row, we have to put this in the first row. So this is going to be row 1, and column, think about it, it's going to be equal to 0. So I'm going to copy this, or actually, you know what, I'll just type that out. Button 1 dot grid. You know, when you talk about the grid, it sort of like sounds like those, you know, cool movies where they're talking about the grid, like some computer system or something. Rows equal to 1, columns equal to 1, and last but not least, button 2, I'll fix a capitalization error, 1 sec. Row is equal to 1 and column is equal to 2. So save this as U, Command S, F5. So now what we should see is our label up top is updating, and we should be seeing some progress. So here comes our launcher. The launcher is loading. It's bouncing, still bouncing. All right, so look at that. Our button 2 didn't come because obviously my spelling mistake over here of the GERD. Save this, F5, I'm sorry about that, guys. But if you notice, we saw that 0 and 1 came out quite nice. That's pretty neat. So 0, 1, 2, 1, 2, 0, 1, 2. Isn't that cool? So we're like 50% done with this calculator app. All we have to do is replicate this entire code that we've written for our rest of the numbers and the plus, minus, divide, multiply, and equal to. All right, so fantastic job. This lecture we learned quite a lot actually. We learned about the global variable. We learned about lambda. We also learned basically how this whole calculator app is going to work by using this function. So I'm going to see you in the next lecture, and we'll be completing basically the rest of our calculator GUI. And we're back. So in this lecture, let's go ahead and create our actually quite good looking UI. Alright, so we have 0, 1, 2, and you know what? I'm lazy. I've been lazy for actually a good amount of my life. So I'm not sure how many I've done, but let's go ahead and do this. So 3, 3, 4, 4, 5, 6. Oh my god, this is horrible. 7, 8, 9. Alright, so these are our 9 buttons. And then we need to create our equal sign and our plus minus negative divide. So, I'm sorry, plus minus multiply divide. So, I'm going to go ahead and call these differently. I'm going to call this plus. Plus. This one is going to be minus. You might call this subtract or something. It doesn't matter. And this is minus. Alright, go ahead and add in 2 more. Again, this is quite a lot of code. You might have thought of better ways, maybe even creating a function to do this for you. So you call this function, the function iterates through these 13 buttons, give them a name and stuff like that. But, you know, this is fine. I mean, this is anyways beginner code. You're just learning, so it's all good. Plus minus, go ahead and add the one for multiply. And last but not least, divide. Alright. And divide. So, guys, if you want to skip forward, you know how this is going to work. If you're wondering how we were supposed to do this, remember, 1, 2, 3, or 1, or actually, I'm sorry. Yeah, so this was supposed to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and this was supposed to be 0. I'm going to go ahead and make those changes. So, if you want to stick around, please do. Otherwise, fast forward. If you're fast forward, good job. If you're still sticking around, cool. We've done button 0, 1, 2, but remember, that's not really what we wanted. So button 0 is going to go into row, let's think about this, 0, 1, 2, 3, 4. So it's going to go into row 4, column 3, I think. Yes, column 3, okay? I'm pretty sure about this. The rest, make sure you make this back to 0. So button 1 will go in column 0. Button 2 will go in column 1. Button 3 is going to go in column 2. So 0, 1, 2. Go ahead and change button 3's text to be equal to 3. I'm going to do that for all the others one as well. So 3, 4, 5, 6, 7, 8, 9. Plus. So for plus, again, you should see the plus key on your keyboard. Again, it's just this shift plus the plus key, I guess. I'm not sure how you want to call it. Minus, exact same concept. The minus sign. Multiply. So there's 2 different ways. What you can do is you can just write X. Or if you're a little more adept at maths, then you normally write a star. So that dot. I usually use a star, so just go ahead and use a star. And for divide, you use a slash. Alright? So I'm going to save this now. Command S. And we got all of this working. Now, the next thing I want to do is I want to change my, what would you say? This stuff. Actually, first, let me go ahead and change my lambda function. So 3, 4, 5, 6, 7, 8. Whoops. Where was I? 9. All right. And for the plus, minus, and stuff, go ahead and just type in plus. Oh, I'm sorry. Plus. Minus, multiply, and divide. Alright, so command S, that looks good. So we have our 4, what would you say, our 4 plus, minus, multiply, divide, our 9 buttons. We've updated the functions. Last but not least, go ahead and update these grids. Alright, so button 2, these look good. Second should be row 2. So button 4.grid, row 2, column 0. Button 5.grid, row 2, column 1. And button 6.grid, row 2, column... I I'm confused. I'm sorry. Button 5.grid, row 2, column 2. That was right. Button 4.grid, row 2, column 1. I don't think column 4 even exists. Does it? Let me think. It does. Yes, it does. I'm sorry. I just had a brain freeze, guys. You can kick me for that later. So, going back to this, just make sure it looks like this. 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. Let's take a look. Yes. So basically, your column section, starting from button 1 through button 9, should look 0, 1, 2, 0, 1, 2, 0, 1, 2. Now for your rows, again, it's quite simple. 1, 1, 1, 2, 2, 2, 3, 3, 3. Alright? My god, that was confusing. Now, the next part we want to talk about is this. So our button 4 is at row 4, column 3. That looks good. Now for our plus, well, think about it. It's going to be row 1, column 3. Okay? Our minus will be row 2, column 3. Our multiply will be row 3, column 3. And our divide will be row 3, column 3. And go back up over here. So for our row, this should become row 3 again. And column, instead of 3, make it 2. Command S, F5. Guys, fingers crossed. I honestly don't know what happened in the middle of that. I sort of had a brain freeze, but hopefully now we should have our calculator. So the Python launcher is loading. Let's go ahead, give it a few more bounces. Doosh, 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 doosh. All right. So, guys, what do you think? Huh? Pretty neat, right? So, it looks like we're missing a multiply and our 0. I'm not sure why, but let's take a look. So, multiply, we said row 3, column 3, and divide also the same thing. So, that was our mistake. Yeah. Everyone makes mistakes, guys. Thinking about this should become row 4. And the row 4 for this was actually correct. My bad. Alright. Command S, F5. I mean, I think this was actually become a very neat Python app. I mean, you know, instead of using those Windows apps and those Mac apps, go ahead, create your own calculator app. And then whenever you're doing homework, whenever you're doing some math equations or sums, use your own Python app. I mean, you'll feel great while doing it, and it's quite cool. So let's go ahead and try this out. 0, 1, 2 plus 58 plus 69 plus 45. Alright, so it looks like we don't even have our equal sign. I forgot to add that. Let's go ahead and do that right now. Actually, you know what? Let's leave it to the next lecture. This has gone long enough. But awesome job, guys. We are now, I think, 99% there. We have all this showing, and now we need to add our equal sign, and we have to, if you're one step ahead of me here, eval this expression. Get it, guys? Eval. So basically all we're going to be doing is calling the eval function on the string and getting the desired output. So awesome job, and I'll see you in the next lecture. Right, so let's go take a look at what's happening. We want to move our 0 back to the middle over here. We want a C sign over here for clearing, and we want this equal sign underneath the 9. Let's go ahead and do that. Basically, go ahead and set the column of 0 back to 1. And for our equals, so I'm going to copy this, whatever this was. But remember, we won't be using this function again, so delete this function right now. This function part of this. Make the text equal to our normal equal sign, and make it equal as the button name. Equal.grade, on the other hand, should be row 4, column 2. Alright, pretty sweet, right? And last but not least, go ahead, call this one clear. So as you already know, every calculator has a clear button that's like C or CA, I'm not completely sure. But pressing on that button basically clears the whole screen. It makes it empty. So that's basically what we're trying to achieve over here. button red text C, row 4, and then instead of column 2, make that column 0. So Command S, F5, and you're not going to see our completed calculator UI. Alright, so now we're going to see our equal, C, everything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, C, equal, plus, minus, multiply, divide. Guys, this is pretty sweet. Alright, even though our equals and C is not working, to be able to create all of this and get it working, that's fantastic. I'm going to go ahead and delete this equation.set function because we no longer need it. What we can do though, however, is say lowercase, equation.set, and then we're just going to tell them, hey, enter your equation. Alright, just give that guy a bit of a heads up that I want you to enter this. Okay, cool. So we need to add 2 functions. One function is for the equal sign, and one function is for the clear. So go ahead and do this. Command is equal to, I'm going to call my function eq or equal press. Alright, go ahead and create this def equal press up top. Basically all it's going to do is def equal press. Is that, yes, okay. Def equal press, doesn't take any parameter. And now think about how this is going to work. Well, we already know we're going to be using the eval function. That's fantastic. But what are we evaluating? This is why we created the equa variable in the first place. The equa variable holds all the string that has been typed by the user. So all this, 23, or actually 56 plus 89 plus 56 plus 45, this whole text is stored in this equa variable. So all we have to do now is create a new variable called the sum or total. Okay, total is equal to eval, and what are we evaluating? Come on, guys, equa. All right, eval equa, and then all we have to do is say equation.set, and we're setting that equal to come on, what is it? Total. Okay, no quotation marks there. Total. Cool. Again, that's in a string concept, I believe, but in case it is not, go ahead and convert this into a string. Equation.set total, and now guys, what is one thing we're missing? So we've set this equation, that's fantastic, but if you're one step ahead of me, alright, and I hope you are, we have to set our equa variable back to our initial thing. So Command C, Command V, ta-da. Run this, or I'm sorry. I'm actually used to coding in Swift. That's the language I love. So running anything in Xcode, you have to type in Command R, and I'm so used to that I was doing that over here. Looks like I'm getting an error, and it says tkinter TCL error, bad option command. Interesting. So I believe we had to put this in quotation marks. Yes, I think I'm correct. Command S, F5. Sometimes you just forget, you get brain freezes, stuff like that. Nope. It's still giving me an error, and it says bad option command. Oh, you don't say, huh? We added our command part to our equal.grid instead of the initialization, so sorry about that, guys. I've added that to my equal button and remove those quotation marks. Command S, F5. Let's take a look. Alright, so it now says enter your equation. So that basically gives the user, hey, looks like I'm supposed to enter my equation. Let's do a simple one. 25 or 5 into 9 gives us an error. Alright, local variable equa referenced before assignment. Alright, so as you can see, when we tried that simple equation, 5 into 9, we got an error. Now you can't see my error. Let me just go ahead and make this a bit smaller so that you can see it. And all it says is local variable equa reference before assignment. And the reason for that is, well, we haven't used our global on the equa. I believe this is the error. I don't think it's the error, but go ahead and try this out. Yes, this is actually the error. The reason why is because we're setting equa as equal to nothing over here, and whenever we were changing a variable, but we want it to be equal to this variable, we have to specify that it's a global equa, that we're talking about this variable up top. Command S, F5, and let's take a look. Hopefully now it'll work. Again, I'm not sure. Let's do a simple one. 5 plus 3. Oh yeah, that is pretty sweet, guys. 5 plus 2 is equal to 8. That worked. Awesome. Let's try something else. 86 into 9. 774. 0.85 minus 6. It gives me an invalid token. So I think the reason for that might be that because we're using that 0, so it's thinking, well, what is this 0? Or it might be just because we have to clear the function out. So let's go ahead and create the clear part. Let's give it a command. So command is equal to, I'm going to call this clear, something simple. Go back up top, say def clear. And what clear is going to do is it's going to say equal. So first globalize equal. Global. Global equal. And then all we want to say is equal to nothing. And our equation dot set should be equal to nothing. So save this. F5. And guys, I believe we now have a working calculator app. So I'm going to move this out of the way. Give this all the room it can get. Let's try some. So 78 minus 9. 69. Clear. 58 plus 3. 61. Clear. 56 divided by 2. 28.0. Clear. That's awesome. And one last, 80 into 6. I mean, guys, I am totally proud of you, alright? Fantastic job. We have created a mind-blowing calculator app. And you're probably wondering, well, why? I mean, this is just a simple calculator app. Well, this is basically the roots of your, this is the roots of you entering into the Python world, alright? Creating this is no small deal. Awesome job. Now, if you've had any questions on this, if you're wondering how did this work, what is Lambda, why are we doing global equal? Anyways, though, I think this is quite a simple Tkinter app. Very interesting, very fun. Any questions? Please leave them in the form. All right. So as you can see, we've created a fantastic calculator app. So pat yourself on the back. That's absolutely brilliant. If you've had any questions along the way, how does this work? How does that work? Will there be anything else? Stuff like that. Go ahead and please leave them so that I can get back to you as soon as I can. Now, this is not the end. You can play around with this. You can add some color. Again, if you're on a Mac, color won't work. But if you're on a Windows, like I was a year ago, then you can add some BG colors. You can give them some properties, make the buttons bigger, stuff like that. Anyways, fantastic job. And this is probably the end of the main Tkinter module. Now, we are going to get on to gaming, canvases, objects like that. So I'm going to see you in the next lecture, and we'll talk about the canvas. All right? See you then. Alright, so in this lecture we'll be talking about the concept of canvas, alright? And I told you that we were going to talk about it in this lecture. I mean, we've covered basically the main GUI elements of the Tkinter module. But we're now getting on to that graphics stage, the graphics stage, I'm sorry. So with graphics comes the canvas, alright? So go ahead and let's get our first few lines set, alright? TK is equal to TK, right? And last but not least, we had, I'm sorry, not TK, but root. We always did root. And then root dot main loop. Alright? So this was basically our main 3 statements that we wrote. And what I want to do now is add our canvas. Okay, so we have our root, and go ahead and create canvas. Canvas is going to be equal to the canvas function. And here you basically specify what frame it's from and maybe the width and the height. So over here it's going to be root. And then let's do width is equal to 400, or something small, 300. And height is equal to 300. And then all I want to do is canvas.pack. Alright, save that, run it, and it's not going to give me a dialog saying, hey, how do you want to save this? So as you know, I always do new projects, so I'm going to call this as canvas Tkinter, save in my documents. Alright, let me move this out of the way for you guys. Cool. So I'm gonna run this again, Command R, whoops, F5 actually, that same Swift issue. But here we go. So the Python launcher loads and I get the error canvas is not defined, obviously, because I spelled it wrong. There we go. Save that, F5, and now what we should see is basically a window, all right? Take a look. So you're probably wondering, well, what's the difference between this and the ones we've created before? Well, the thing with this specific window is now we can add objects, rectangles, arcs, ovals, ellipses, you name it. We can create those shapes, fill them, add colors, add animation, all through this canvas module. So again, it's very cool. Let me just go ahead and end this lecture with a simple statement. So let's say we're talking about rectangles, all right? I want to create a rectangle. How does this work? You call the function canvas dot, and then if you let's you come, just go down, and you want to go to the create section, okay? You have all these different things you can create. You can create a window, you can create text, you can create a rectangle, polygon, oval, line, all this random stuff, and we're going to get to some of them, not all of them, but at least some of these creations. We're going to say create rectangle. And the create rectangle function takes in a lot of parameters, but 4 basic parameters. And these parameters are the x1 and y1 coordinates and the x2 and y2 coordinates. So if you know what I'm talking about, great. Otherwise, don't worry. I'm going to explain it right now. So I'm going to choose a 300 by 300 sized thing, all right? Suppose this is my rectangle. Oh, no, actually, this is my screen, all right? This is my 200 by 200 screen, and I want to create a rectangle that starts from here and goes all the way down to here, okay? So let's say I want to create this. How would this work? Well, the parameters the canvas.create rectangle takes is this point. So let me go ahead and change the color over here to make it nice, and you can take a look. So this point, this is x1, comma y1, all right? And the second parameters, or the second parameters it takes is this one. So the x2, comma y2 parameters, all right? So let's say I wanted to create this rectangle. What's the x1, y1 coordinates of this? Well, just to let you guys know, the top left corner of our canvas will always be 0, comma 0. So right now, when we created this 300 by 300 square, I guess, this end of it, this end right here would be, if you're a little ahead of me, 300 by 300, okay? So what is this point? Well, to the x, you know that this whole thing is 300. This might be about 20 or 30. So let's call this 20. And as you can see with the y value, it's going to be 20 as well. So let's do 20, 20 for the x1 and y1. Now moving on to x2 and y2. So x2, as you can see, if this was 20, this is probably 100, all right? It's about a third. So let's go ahead and put 100 as the x2. And what's y2? Well, you know that the full width, right, is 300. And it's ending over here. So this might be 270, all right? So our final parameters are 20, 20, 100, and 270. Let's go ahead and try it out. 20, 20, what did I say? I'm sorry, brain freeze. 100 and 270, all right? So there we go, save this, and F5. Let's take a look. So opening up my shell, ta-da! So going to Paintbrush and comparing, what do you think, guys? Pretty close, right? So hopefully you understood how this creation of objects work. Basically, you call the function create blah. It can be an arc, image, rectangle. Again, we'll get to those. And the parameters it takes is the x1 and y1 of the top left of that object and the bottom right coordinates of the object. So the x2 and y2. Awesome job, and I'll see you in the next lecture. Alright, so in the last lecture we left off where we learned, hey, this is how the canvas module works. We learned how to create a very simple rectangle, and we understood what parameters are being given into the function. Alright, so we've created a rectangle 20, 20, 100, 270. Again, that looks good. And if you think about it, let's go ahead and compare this turtle module to the Tkinter module. With the tkinter module, all we had to do was say canvas.create rectangle 20, 20, 100, 270. With the tkinter, I mean, that's a lot of work. You'd have to say go forward, then left 90, then go forward 50, then left 90, then go forward 200, then left 90, and it goes on and complex stuff. Tkinter really simplifies it. So again, for all GUI, or at least the GUI that we'll be doing later on, we're going to be using the tkinter module. Alright, so we created a very cool rectangle. Now the next thing I want to talk about is, let's say, lines. Alright, so how does a line work? So let's go ahead and create a line. And basically, it's the exact same concept as a rectangle. You want to give well, actually for the line, it's the starting point's coordinates and the ending point's coordinates. Alright, so let's say I gave you the challenge, hey, create a diagonal line. Alright, so basically the first thing is canvas dot, and then you can wait for the pop-up, or you can just type it by yourself. It's going to be create line. Alright, and in the line function, again, it's basically the beginning point's coordinates and the ending point's coordinates. So if I want to create a diagonal line, alright, I know that the top left of my screen is 0, 0. Remember? In our paintbrush, we talked about this. This is 0, 0, and the bottom right is 300, 300. So all we have to do is say 0, 0, 300, 300. Alright? And what this will do is create a diagonal line starting from the top left corner going all the way to the bottom right. So Command S, F5, and if we take a look, what do we get? We get a nice looking rectangle and a diagonal cutting it. Pretty cool. So let's continue on with another shape, I guess, with the canvas module. There's tons. There's the oval, there's the arc, there's quite a lot actually. Let's go ahead and talk about one more for now in this lecture, and then we'll move on to some other stuff in the next lecture. Again, most of them are straightforward, alright? There's not much to it. Let me get that drop down again, or back over here, dot. Give it a few seconds, CRE, okay? So you can create an image, you can create a line, you can create an oval. Let's go ahead and create a polygon, all right? So with polygons, going back to paintbrush, okay? I'm gonna Command Z most of this so that I get a nice clean sheet if I can. No, I can't. Basically, what the polygon is, you have to specify more than 3 pairs of points. For example, if I was creating a polygon like this, so and tarant, connect the dots, ta-da, like this, alright? What I'd have to do is specify each coordinate, alright? So x1, y1, x2, y2, x3, y3, x4, y4, x5, y5. And then Python would go ahead and connect the dots like we just did. So if we're calling the create polygon function, again, we have to specify quite a lot of coordinates. I'm going to do some simple ones. Again, if you've got the idea, create any polygon you want. I'll do 0, 0, 0, or let's do 5, 20, I guess. And then if I'm thinking this correctly, I'll take it's a bit confusing. Give me a sec here. 50, 30, and then let's do 40, 15. That's it. So basically, if you think about it, going to paintbrush and deleting what I just did, the way this would work is 0, 0 would be here somewhere. Again, think of this as the new frame. So if this was the frame, 0, 0 would be somewhere over here. Let me change the color so that you guys can see. This would be 0, 0. 5, 20 would be somewhere over here. Oh, you can't even see that, my bad. Let me change the colors. 5, 20 would somewhere be over there. 50, 30 would be, again, more to the right and a little bit more down. So that's 50, 30. And then 40, 15 would be this. So I sort of created a rhombus. Not a rhombus, maybe a parallelogram, I don't know. But save this, F5, and let's see what we created. Let's see. Cool. So again, it's a bit demented, but we've created a very interesting shape. And as you can see, it's filled it with a black color. Now, if you guys remember when we were talking about the Tkinter module, the colors weren't working. We weren't able to change the colors and stuff. However, I can assure you that with the canvas module, the colors do work. Alright, it's a lot of fun and you can create all sorts of colorful objects, and we'll get to that in the next lecture. Hi guys, so in this lecture, I want to talk about functions, alright? Now, all this we've created can also be done in functions, okay? Now, the way this function is going to work is we're going to pass in some parameters. We're going to specify what the x and y coordinates are going to be, and then it's going to automatically create for us a rectangle, alright? So, it's not something that huge, but it's going to be fun. So, let's get started. I'm going to delete these two canvases. We don't need them anymore. And as you can see, I don't have that tk.main loop anymore. That's been gone. Again, you know, it's something you can add. I definitely recommend you add it. I'm not sure why that's been deleted. root.main loop. That's one thing that's been missing for some time. Okay, so for the functions again, it works just like all other functions. You can say something like def create rect. Alright, and the parameters it takes is x1, y1, x2, y2. Okay, and let's say we wanted to create all our rectangles in a blue color. Okay, blue color. So because blue is awesome, blue's my favorite color. You can change your color to whatever you want. But basically, this function is gonna work like this: canvas.create rectangle, and then in the parameters x1, y1, x2, y2, comma, fill is equal to blue. Alright? So now that we've created this rectangle, there's no need for us to, write this canvas.create rectangle. We have shortened it into create rect. Okay? So create rect, right? Let's do 5, 50, 200, 70. Yeah. Okay, then let's do create rect. Let's do a tall one this time. 5, 5, 240, 200. Something random, okay? But hopefully now, I'm sorry about that. Hopefully now you should be understanding how these coordinates work. Again, if you have a Cartesian plane in your mind, you know how the x coordinates are, you know how the y coordinates are. Again, it's simple algebra. You might have forgotten it by now, but it's quite vivid in my head. So save that and let's take a look at what we're creating. My Python launcher has appeared and let's see. So it gives me an error, xy is not defined. Obviously it's not defined. Why? Because it's a mistake. Darn. F5 again. Save that and okay. Alright, launcher's coming again. Let's take a look. Yay! So let's see. This worked quite brilliantly. We created two rectangles. Both of them were blue. Pretty neat, right? So this was very interesting. We learned in this lecture how we can use functions to create rectangles, or actually any shape for that matter. And we also learned about filling. So the color, right? We learned how to create such, or how to fill objects by using the fill parameter. Now in the next lecture, we're going to do something fun actually, and we're going to be creating something called a random rectangle generator. Alright, and the way this is going to work is the user, alright, will specify basically how many rectangles they want from 0 to, let's say, 150, any amount of rectangles they want. And then what we will do, based on our function, we're going to create that many rectangles, except each rectangle will have a different width and a different height. So it's going to be a smorgasbord of rectangles. The whole screen will be covered in rectangles and it's going to be a lot of fun. So see you then. Alright, so let's get started with our random rectangle generator. Alright, so it's going to be a lot of fun and let's get started. First thing first, what I want to do is import random. Alright, this is the module that we've talked about in previous lectures, and this is the module that will generate those random numbers. Now, the function we're going to be talking about today will be the rand range number, or rand range function. So I'll talk about it in a bit, but let's get our starter code there. Create the function. I'm going to call it random rect. All right. So, and it takes in one parameter, and the only parameter that we're taking in here is number. So number of rectangles, right? And based on the number of rectangles, we want to create all those random rectangles. So for I in range, and there's different ways you can do this. I'm just going to say 0 to num. Okay. What do I want to do? Well, I want to, first of all, get our 4 coordinates. And the way I can do this is by saying x1 is equal to random.randRange, okay? And then I say 300. And all this does is, well, it takes a look at what's happening. x1 is equal to random.randRange. And all randRange does is it generates a random number between 0 and the number I've specified. So let's not do 300 actually. Let's do 100 for now. All right, or let's see. One sec here, guys. Yeah, let's do 150, because if we generate a random number between, well, actually, no, I'm sorry, guys. Just do 300. 300 is fine. We'll take a look later on. So next one is y1. Y1 is equal to random.randRange, and do 300 again. Then the next one we want to do is what x2 is equal to x1 plus random.randRange 300. So do you understand what's happening here? Remember, whatever x2 and y2 are, they will always be greater than x1 and y1. Why? Because x1 and y1 will always be in a position that's, well, less. So x1 and y1, x1 and x2, x1 will always be more to the left, x2 will always be more to the right. Basically, x1 has to be less than x2. Same way with y2, we're going to say y2 is equal to y1, whatever y1 was, plus random.randRange 300. All right. And then last but not least, all we have to do is call canvas.createRectangle. And for simplicity, I guess, create rectangle. Don't fill it up, or I might fill it up with black. Just leave it at black. Canvas.createRectangle, and then just pass in our 3 coordinates or 4 coordinates. Awesome. Save this, F5. Nothing's gonna happen. Why? Well, probably because we haven't specified anything. You can try and call it, it won't work. It won't work. It just won't work. You see, you get nothing. So go back to our code. Go ahead and call this function now. Function is random recs, and let's say I want to generate 20 random rectangles, or let's start with 3. F5, and let's see if we even get 3 rectangles. Hallelujah! Take a look. So we've gotten 3 rectangles, and again, it's overboard. All right, it's going off the screen, and you're probably wondering why. The reason for that is because if you think about it, we're specifying x1 and y1 to be a random number from 0 to 300, right? However, if you think about it, let's say x1 is 270. And then for x2, we're saying 270 plus a new random number. What if that new random number is maybe 300? So it's going to be 270 plus 300, 570, and it's going to go way off the screen. So instead of specifying a random number between 300, do it between 150. And the reason for this is, let's say x1 becomes 150, and then miraculously, this random.randRange function over here also returns 150. It'll be 150 plus 150, which is 300, and which is the width of our screen. Okay? Hopefully that made sense too. Basically, all we're doing is we're setting it back to 150 so that the rectangles stay inside of our screen and do not go outside. Take a look. Nice. So we got 3 rectangles. let's go ahead and create some modern art. And by modern art, I just mean random rectangles. So let's go ahead and increase our random recs to 150. This is going to be a lot of fun. F5. Wow. You know, this type of art sells for millions of dollars, and you created it via Python, so that's even way cooler. Awesome job, guys. Okay, so this is our random rectangle generator. Play around, give it some color. One very neat feature you could probably try, all right, listen to me. So we talked about the shuffle function, right? How you can shuffle a list. What you should do is create a list of colors. So blue, yellow, green, red, white, magenta, gold, all right? Once you have your 7 or 8 colors in a list, shuffle the list every single time this function is called, and then go ahead and add the parameter fill is equal to that color, all right? And by doing so, each rectangle will have a different color, or not each rectangle, but it'll have differentiated colors and it'll look cooler. So one thing you can definitely think of, again, awesome job. This was just to create a random rectangle generator, and we accomplished that. Now we're almost done with canvases. Obviously, we're going to talk about it more during the animation section, but for now, we're slowly getting to the end of our whole Tkinter section. Alright, so we're not done yet, guys. I know you're probably like, oh my god, more Tkinter stuff. You want to move on to the good stuff, right? And I do too, but I want to cover a few more stuff, or a few more things. First one's an arc, alright? I'm sure you might know what an arc is. Again, if you've studied circles, if you've studied how circles are, you might know something called maybe the minor arc and the major arc. If you don't know what I'm talking about, basically, this would be a circle. You would make this as the minor arc, and then this would be the major arc, something like that. Again, I'm not too good at explaining what's going on over here, but an arc, again, an arc is basically a curved line, right? So to create an arc, all you have to do is say canvas.createArc, and then you specify, hey, how do I want to create this? The way arc works is, well, actually, you know what? Let's go ahead and create some, and then I'll explain actually what's happening. So do this. Let's go ahead and create a few arcs. First one's going to be 10, 10, 200, 80. Okay. Second one is, or actually, you know what? One sec. Let me think about this. 10, 10, and then 200, 80. Alright, so yes, I know what I'm doing. So 10, 10, 200, and then 80. And then what I want you to do is go ahead and specify a parameter called extent. Okay? And basically what extent does is, what if you don't want to create the arc all the way? If you want to do maybe 1/4 of it, 45 degrees, 90 degrees, 180, or maybe the whole thing, which would be 359 in this case, or maybe 360. So extend, let's go ahead and try 45 for now, okay? And then go ahead and just specify the style to be equal to arc, okay? Copy this, Command C, create one more. Now this next one's gonna be 10, 80. So we're bringing it down a bit, all right? Instead of 10, 10, we're bringing it down to 10, 80, and then we're specifying 200, 80. Okay? So that basically means 200 pixels across, and so on and so forth. So that's that. Make sure you can change the extent a bit, maybe 90. Save this, F5. Let's take a look at what happens. Alright, so as you can see, we now have this 1/4 of an arc, and we have a straight line. So let's go ahead and talk about this code. Again, you might not have understood what's happening, and let me quickly explain what's happening. So over here, you have 10, 10, 200, 80. So think about an arc, alright? I'm going to open a new paintbrush, and that's because that's the best way I can actually explain to you what's going on. So let me create one, okay? Think of this as an arc, alright? Or more like this and then this, okay? This is an arc. We want to create this arc. What Python sees is this, okay? Not really that, but I'm sorry. Command Z, something like this. Yes. This is what Python sees, alright? when we're specifying that the top, these coordinates, 10, 10, 200, 80, we're basically specifying to Python, hey, I want you to create an arc whose rectangular coordinates are 10, 10, this would be 10, 10, and this would be 200, 80. And then inside of that rectangle, Python would create an arc, all right? So if you're wondering, well, looking back at our Python simulator, this doesn't look like 80. Well, obviously it doesn't. This is, I believe this is probably 40. And then if you go down a bit more over here, this would be 80, all right? The reason why we got a straight line is because these two are clashing. Go ahead and change this from 80 to 160 so that it brings it down 80 pixels more. F5. And now we see, ta-da, so this is 45 degree, 90 degree, 180 will get you all the way across. 359 will make a complete oval. Now you're probably wondering, well, 360 degrees is a circle. We're using 359 instead of 360 because Tkinter considers 360 to be same as 0 and wouldn't draw anything. Cool. So we talked about ovals, or I'm sorry, arcs, and ovals, ellipses, they're basically the same concept. Let's go ahead and talk about text, because if you're creating any game, if you're creating anything in GUI, you want to display some text. Hey, this is my app, it's created by me. This is the title, stuff like that. So to create text, and text is actually quite awesome, quite simple. So you say canvas.create, and then you use the text function, so create text. Then over here, you specify where do you want to create this text, right? The way this works is basically the top left, or the sentence will be positioned at these two coordinates, not actually one coordinate. So canvas.create text, let's say I want to do it in the center, maybe 150, 150, and then you can specify what the text is. This is my first GUI text, and it is awesome. Yay! Save this, F5, let's take a look. Python module, as you can see, it's now centered. So the first two parameters of the text basically says, hey, where do you want to put this text? I mean, it's basically the middle coordinate of the text. So 150, 150 is like this middle point over here. And then all we did is we specified what the text is. Again, remember, you can change the text, or I'm sorry, you can change the font, you can change the font size. The way you would do this is actually, it's quite cool. We have this, we can now say font, and then you specify, equal to, and then in brackets, you specify the font type or the font family. You can do, let's do times, I guess, Times New Roman, and then you specify what the size is. So I'm going to do 30. Save this, F5. Let's take a look. Invalid syntax. What's the error? It says random rex is not defined. Why is that giving me an error? Oh, I'm sorry. That random rex should no longer be there since we've deleted that. F5, invalid syntax again. Oh, it's giving me an error for the font. That's odd. Delete the equal to, that might be an issue. F5, does that work? Yes, it does. So going over here, it's a blank screen. Wah, wah, wah. So I guess for the font, that's odd. What can we do? So looking at this, the font equal to is not working. Normally it does. So, oh, I see. Duh. We forgot a comma over here. By specifying the comma instead of a period, we should no longer see the error. And taking a look, wow. So it's big, it's black, and it's awesome. Awesome. Cool. So as you can see, we've now been able to change the font size. We were able to change the font family. And if you're wondering how to change the color, it's fill. So you can say fill is equal to maybe white. You know, if you're changing the background to black, stuff like that. But awesome job. Alright, so we covered a lot. As you can see, I've deleted my code now so that I can prepare for the next lecture. However, we talked about arcs, we talked about text, and that's fantastic. I won't be talking about images again. It's not too necessary right now, and you might run into an error or two, but you can fiddle around. Again, there's some great online resources for learning some Tkinter stuff. But in the next lecture, and this will probably be the end or the finale of this whole Tkinter section, we're going to be talking about animation. So moving objects, creating some basic animations, and then we'll work on this, alright? So we'll build upon this and then create our full-fledged gaming apps later on in the future. So see you then. Hi guys, welcome to the final lecture on our Tkinter section. I think this is the final lecture, I'm not completely sure, but let's get started. Today we're going to be talking about animation. Animation is the core concept of all things GUI, alright? Without animation, you can't have any sort of amazing GUI app unless, of course, it's just user input. Otherwise, if you're gaming, if you're doing other stuff, you want to always have animation. Now, this is where the time module comes in. Now, if you remember back in like section 5, 6, I'm not even sure what section it was, we talked about the time.sleep, right? And what did time.sleep do? Well, it basically paused the program. For example, when you're printing 1 to 100, every single time a number was printed, our program paused for a second. It was neat, right? We could, say that after every second, I want this to happen. After every half a second, do this. Well, this is where animation will come into play with this time.sleep. So go ahead and create something. Create anything you want, but make sure it's an object. I'm going to go ahead and create a polygon. And this polygon is going to look like a triangle sideways, basically a play button. I'm sorry. Excuse me. So canvas.create polygon and then specify the coordinates. Again, I'm a bit, I got the coordinates down. So just copy what I'm writing, 10, 10, 10, 60, and 50, 35. Okay? So save this, and now down, what do we want to do? Well, think about it like this. We want to move this object, and then pause for some amount of time, then move the object again, then pause for some amount of time. So go ahead, remove this import.random, and instead import time. Okay? Now for I, let's say I want to move this 60 times. For I in range 0, 60, okay, I want to say canvas.move. Okay, so you're wondering, well, what is canvas.move? Canvas.move basically moves the object you have on your screen by a specific amount. Okay. So the parameters canvas.move takes, well, let's take a look. So canvas.move, suppose we said, just write this for now, 1, 5, 0. Canvas.move 1, 5, 0 states that you're moving object ID 1, all right? So object ID 1 is the identifier for the triangle, all right? Triangle is, again, the create polygon we created. Now we're moving the first object, and then we're specifying how many pixels are moving it in the X and in the Y. So right now we're saying that we want to move it 5 pixels forward every single time this function is called. Looks like I caught my spelling mistake. So for I in range 0, 60, canvas.move 1, 5, 0. Again, what is it doing? 1 specifies that it's the polygon. If you're wondering, well, we haven't specified any identifier. Well, the way this works is whichever shape you create first. For example, if I created a polygon and then a line, polygon will get the ID 1 and our line will get the ID 2. Okay? Canvas.move 1, 5, 0, moving it 5 pixels to the right each time. Then you have to call tk.update. And what tk.update does is it basically, I'm sorry, not tk.update, root.update. Root.update basically updates your whole canvas, your whole screen in case there have been changes, and as you can see there have. And then we're going to say time.sleep 0.1. So this whole code that is being executed every time, you want to make it sleep by 1/10 of a second. So Command S, F5, and let's take a look. Okay. Here's our Python launcher. Open. Wow. That is some impressive animation. We have just made a triangle move off our screen. Yay! Nice job, guys. So if you didn't understand what's happening, go back to our code. Let's take a look. For I in range 0, 60, we're just saying 60 times. Move our canvas 5 pixels to the right We're not really moving our canvas, but the polygon, which has the identifier 1. We're then updating our screen and then making our program sleep by a 1/10 of a second. So this is probably a very basic introduction to our animations. Now what you could do is, we've talked about binding, right? We know how binding works. We do the canvas dot or the root dot bind all. You specify which key, and then you specify the function. Then in our function, we pass in the parameter event and we do something. So here's a challenge for you. I won't be giving the code for this, but every time I press the enter key, I want my triangle to move 5 spaces to the right. Okay, maybe 10. Let's do 10 spaces to the right. Okay, every time I hit my enter key, I want it to move 10 spaces to the right. So hopefully you know what's happening. Again, go back to the key binding, understand what we did there. Maybe use some online resources. Again, we'll talk about this more in our gaming section, but if you can do this, fantastic. Anyways, this is it for our whole Tkinter section. If you had any questions so far about all the lectures we've covered, from buttons, checkboxes, menus, I don't even know what we covered, but everything we've done so far, if you've had any questions whatsoever, please don't hesitate to ask. I mean, I really want this to be, a fun class. I want this to be open. I'll try my best to answer any questions you have. If I don't, I'll definitely find them for you and get the answer for you. That's it for this lecture, and I'll see you in the next section. Hi there, in this video we'll be creating our very own game. I hope you're excited for this because it's going to be a lot of fun. I know I am, so let's begin. Open up your IDLE. And for this, because it's a pretty big thing, let's do it in a new file so that you can save this program. So in our new file, let's begin our game. So our game is going to be quite simple. I'm sure you must have played the game Bounce before. Basically, you have a paddle and you have a ball, and the ball keeps on bouncing around until you miss it with the paddle, and then the ball will hit the bottom of the screen and the game will pause. Now you can add many more things to the game. You could add like the bricks and the stuff, so if the ball hits the brick disappears and the ball comes bouncing back. But that's quite more complicated and we don't have a lot of time for that. But first, let's at least create the basic version of the game. Well, let's get started. So the first thing we need to do is create the game canvas. So let's use what we know from Tkinter, import star, import random. We'll be using this module, and we'll obviously be using the import time module. Alright, so initialize our TK. So we have our own TK, and then initialize the canvas. But before we do that, we'll be changing it up a bit. So we'll be adding a title. tk.title is equal to bounce, and we'll be seeing that tk.resizable is 0, 0. Now you must be wondering, what does this resizable do? It basically states that once our TK or once our canvas is initialized, you won't be able to make it smaller or bigger like for this. Like right now, we can make our screen bigger and smaller, but once we say tk.resizable 0, 0, it means that it will stay the size it is. You cannot make it smaller or bigger. Now we'll be saying another new feature that we haven't talked about before. It's going to be tk.wm underscore attributes topmost or minus topmost, comma 1. Now you must be really confused you must be wondering, what does this mean? tk.wm underscore attributes topmost, comma 1. This basically says that we tell Tkinter to place the place the window containing our canvas in front of all other windows. So that's what the topmost means. It should be in front of all other windows. It should not be hidden by any other window. Next, we'll be initializing our canvas. Canvas is equal to canvas, taking in our parameters tk, width is equal to 500, height is equal to 500, and we'll be adding one more parameter, or a few more. BD is equal to 0, and but highlight thickness is equal to 0 as well. So BD basically is the border, and the highlight thickness is also part of the border. Basically, these two things will just make our game look better on screen. Last but not least, we need to do our two most common lines, canvas.pack. So this will create it, and tk.update. Awesome. So Command S, let's just call this bounce. Great. We save this. Let's do F5, run it. And we have our bounce. Great. So if you try resizing, you can't. So this is our application or our game. And in this game, we'll create all our objects. We'll be creating a ball, the paddle, and then we'll start playing our game. So let's go back to our bounce and let's start coding. All right. Now what we have to do is create the ball class. We talked briefly about classes and object-oriented programming before, but the concept is quite simple. So we need to create a ball class that takes the parameters for the canvas and the color of the ball we're going to draw. So let's create a new class ball, and let's add some functions to it. So def initialize, so def init, and it's going to take the parameter self, canvas, and color, i.e. what color of the ball we want. Click colon, all right, and in this function, self.canvas should be equal to canvas, and self.id, so its id should be equal to canvas.create. We'll be creating the ball here. So canvas, let's just create an oval. So create oval, and we want the oval to be 10, 10, 25, 25. So it's going to create for us an oval, and the color should be, if you remember, using the last parameter, color. Great. Last but not least, we want the canvas to move. So self.canvas.move. So here we want to position the ball in the center of the screen. So whatever the self.id is, that's going to be its initial position, and we want to make it 245, 100. So sort of centered in the screen approximately, and then we want to create one more function, and it's going to be def draw, and we're going to leave this blank for now. Pass. So in this will come our animation. This is just the initialization. So if you didn't get this, let's just go through it one more time. We first called our class ball. So we created our own class, we called it ball. Then we created an initialization function that takes the parameters canvas and color. So obviously it's going to take itself, the canvas, and the color. At line 3, or self.canvas, we're going to say we set the object variable canvas to the value of the parameter canvas. So self.canvas will be used in the ball class, and that should be equal to canvas. In the next line, we're saying that we're creating the ball itself. So self.id, we're calling the create oval function with 5 parameters, the xy values of the coordinate for the top left, then 25, 25 for the bottom right, and then we're just saying what color do we want to fill it with. Awesome. Now what we want to do is we want to move the ball so that it's centered. So in our game, we don't want the ball to start off somewhere over here. We want the ball to be in the middle. So we're saying self.canvas.move self.id, so wherever it was before, to this 245, 100, which is approximately centered. Great. In the last 2 lines, we're creating a new function called draw, and we're just simply passing the keyword pass like we talked about before. This won't do anything at the moment, but we'll be using it later on. Awesome. Now that we've created a ball class, let's initialize it. So just click enter, and let's say over here ball is equal to ball. So we're calling the class, and then we have to initialize it with the canvas and then the color. So let's create a red ball, red, And now if we run it, let's try running this program. Command S, F5, and we got this. Awesome. So we now have a ball and it's approximately centered. So let's close this. Another thing we have to do is we have to create a main loop which will keep on updating the canvas so that it'll always show the ball moving. So let's create a while loop, while 1. So this will run forever. tk.update idle tasks. Yeah, we're using a lot of new stuff here, but I'll explain it all. tk.update, and then we're going to say time.sleep 0.01. So all we're saying here is our main loop, so our while 1 loop, is all it's saying is that tkinter redraw the screen. So we're updating the idle task, so whatever is going on in the background, and we're updating the foreground as well, and then we're causing it to sleep. So while the ball moves, it'll keep the canvas will be updating as the ball moves, and we'll get to see the animation. Awesome. So now we've created our ball class. We have created a small while loop. Click F5. You shouldn't see any difference. Great. So we have a ball and almost in the center, a little bit off, but that's fine. And now we have to add some action. We want the ball to move. So we're in the def draw. We are back here. So we want to remove the pass now, and we want to add some action. So we have to animate the ball to move. So let's say self.canvas.move, self.id, so wherever it is right now, and let's do it 0, -1. So it'll start moving the direction to the left. Since init saved the canvas parameter as the object variable, we will use that variable with self. So you must be wondering, why are we using self here? Why not just canvas.move? It's because we used it as a parameter, we have to initialize it. So self.canvas is equal to canvas, initializes it, and then wherever we want to use the canvas, we have to say self.canvas. Now we pass 3 parameters to the move. The ID of the oval. So remember, the move parameter always takes 3. The move function always takes in 3 parameters. The first one is the ID. The second one is how much you want to move to the right or left. And the third one is how much you want to move up or down. So here we passed in the ID of the oval. So that's the first one check. Second one is saying we don't want to move horizontally. We want to move up. So -1 basically says move 1 pixel up. So I know this doesn't do much, but it's good to just try it out to see if it's working. So it doesn't seem to be working, and let's see why. So our ball is not moving up. Something seems to be wrong. The reason is we are not calling on the draw function. Obviously, we have to call on it. So let's add in our while 1 loop ball.draw. Hopefully you got that. If you don't, let me explain it right now. Def draw is a function of the ball class. This will not be executed unless we call upon the function. So in our while loop, which will run forever, we want the ball to keep on moving. So we call the function ball.draw. Command S, F5. Now let's see. There we go. And our ball is off the screen. Great. So now we're creating a moving ball. That ball just went off the screen, but it's a start. Alright, great. So now our ball is moving off the screen. In the next lecture, we'll be learning how to create parameters for the ball to stay in the screen. So if it hits the end of the screen, it'll bounce back. And then we'll be adding the paddle and doing much more. See you in the next lecture. Hi there. So in the last lecture, we left off where our ball was just moving off the screen. It wasn't doing anything. So if I F5 our code and it runs, you can see that the ball just moves off the screen. And we don't want that. So what we do is we're going to add a few additional objects so that it doesn't move off the screen. Alright, so let's do this. let's go back to our class ball and let's add a few stuff. So after we've done the self.canvas.move, we want to specify what the canvas height is and our x and y variables. So self.x is equal to 0, self.y is equal to -1, and self.canvas height is equal to self.canvas.winFo height. Now, obviously it's 500, but that's fine. So we've added 3 more lines to our program. The self.x, self.y, and the self.canvas height. With the self.x equal to 0, we set the object variable x to 0. And the self.y is equal to -1, we're setting the variable y to -1. Finally, we're setting the object variable canvas height to the height of the canvas by calling the function winFo height, which just returns our canvas.height. So it's quite simple, and now we have to modify our draw function. So at the moment, all it's doing is saying self.canvas.move self.id 0, -1. What we're going to say is instead of 0 and -1, we'll be using self.x and self.y. Now, if you didn't understand that, let me try explaining it to you. Basically, we can now control these variables. So we can control where the ball is going to go. If you change the self.x, it'll change where the ball is going. If you change the self.y, it'll change where the ball is going. Quite simple. So click enter. Now we need a position. So just follow me here. It's a bit confusing, but I'll explain it. Post is equal to self.canvas.chords self.id. And then we're going to say if pos1 is less than or equal to 0, self.y should be equal to 1. So I'll explain it, don't worry. Just let me just finish typing this out and then I'll explain. And then we're going to say if post3 is greater than or equal to self.canvas_height, then we want to say self.y is equal to -1. Awesome. So this is actually some quite intricate and cool code. In the beginning I explained, we changed this to self.id and self.x, self.y. So we're using now the x and y here. We initialized 2 variables, x and y. We made that 0 and -1. So technically it's 0 and -1 right now. Then we used position or post is equal to self.canvas.chords self.id. Now you must be wondering, what is this stuff? All we're saying here is self.canvas.chords. The .chords returns us an array. So it's going to give us an array with x1, y1, x2, y2. So you're like, you must be wondering, how does that help us? We don't require any of this. Well, we do. So by calling the function self.canvas.chords self.id, we pass in the id parameter, which was our id, and it'll return us this, an array which stores our coordinates at that moment. And using that, what we can do is we can check. So pos1, so post square brackets 1, what does that refer to? y1, because remember 0, 1, 2, 3. So we're saying if this value y1 is less than or equal to 0, self.y is equal to 1. So this is pretty cool. All we're saying here is if the ball's height, so the top of the ball, y1, if it's less than or equal to 0. So remember, in the bounce, the top part, this part is 0, and anything above this is less than 0. Remember, this is 500, this is 0. So quite simple, 0, 500, anything below 0 will be considered over here. That's not on our screen. So we're saying if the ball is equal to 0 or if it's less than or equal to 0, then we were making self.y equal to 1. So if this gets run, what do you think will happen? The ball will start moving in this direction. It'll start moving down. Why? Because here we're saying self.canvas.move and we're passing the parameter self.y. So from -1, it's going to change to 1 and the ball will start moving down. Now here we're saying if position 3 is greater than or equal to self.canvas_height, then we're saying self.y should be equal to -1. So it's the exact same concept. So whatever the height of the canvas is, so down here, if it's more than that, so over here, or if it's right at the 500 mark, then what we want to say is make self.y equal to -1. So it'll start going back up instead of going down. So that was some pretty complicated code. Hopefully you got that, and it shouldn't be too bad. But one thing we can do here is let's just print out pause so that you understand what's happening. Command S, F5, or one sec, before we do that, let me just delete this array. Command S, F5. Awesome. Alright, so we have our bounce. Now look at this value. It's going to 0, and as soon as it hits 0, it started increasing. So our ball is now moving back. It's moving back. It's moving back. Now watch this fourth value, the one 290, 300 one. You will see right when it hits 500. So 440, 50, 60, 70, 80, 90, 100, and boom. So it hit 500 and it started decreasing. Awesome. So hopefully you got the concept, but now we've created a ball, and the ball can now move between the top and the bottom without going off screen. Great. This is awesome. Now we have created a good ball. It's moving up and down, but actually we wanted to do more than that. We want to change its direction. So let's close this. Program is still running. You want to kill it? Okay. All right. And let's start changing the ball's starting direction. So at the moment, what's happening? It's just going up, down, up, down. We want to move it left, right. All right. So making a ball bounce slowly up and down isn't really much of a game. So let's enhance things by changing the ball's starting direction. So right now we have these lines. Self.x is equal to 0. Self.y is equal to -1. We don't want that. All we're going to do right now is say, let's create this. Create a new array. Let's call it start is equal to, and then let's create an array of -3, -2, -1, 0, 1, 2, 3. Now, if you remember, what was the function of the random module used to get a random item from an array? If you remember, great. If not, don't worry. So we won't be using that. Instead, let's just use the shuffle. Random.shuffle. Random.shuffle. And what are we shuffling? We're shuffling our array start. So we'll shuffle this, and then we're going to say self.x is equal to start 0, and then y should be -3. So it should speed things up a bit. Awesome. So hopefully you understood that. If not, I'll quickly explain. But first, let's run this to see if it's working. Source must be saved. Okay. So here's our Python shell. Awesome. So now you can see that the ball is moving in a different direction. This is what we wanted. But we forgot to change two things. So actually we need to update our code with a few more things. Let's close this. Do you want to kill it? Yes. First thing first is we want the ball to move faster. Right now it's moving too slow. So that's why we said -3. And if you're not getting why we put the minus and why not plus, because if we put the plus, the ball would come straight down and we would not have time to react with our paddle to hit the ball back. So obviously the ball should start by going up so that the user has time to react. Over here, self.y and self.y, let's make that 3 and -3 so that the ball moves a little faster. Now, right now, our top and bottom are secure, but our right and left are not secure. If the ball goes to the right or if the ball goes to the left, then it goes out and there's nothing we can do. So let's fix that. All right. So let's create a new variable over here. Self.canvas underscore width is equal to self.canvas.windfo. So it's the exact same function, but just width. So now we've initialized another variable, canvas width. And if you remember, as I was talking about the coordinates, what does it return? x1, y1, x2, y2. So we've already called upon the y1 and the y2. Now we have to make sure that it does not go beyond the x1 and the x2. So it's quite simple. If pos 0, so we want to call the x1 this time, is less than or equal to 0, Then we're gonna say self.y, self.x should be equal to 3. And if pos2 is greater than or equal to our canvas dot or underscore self.canvas.width, then what do you want to say? We want to say self.x should be equal to -3. So again, this was the exact same concept as this. If the position of the ball, the starting or the leftmost position of the ball is at the end or the leftmost side of the canvas, or if it goes beyond the left side of the canvas, i.e. 0, then we want it to start going in the right direction or start going to the other side. And if it's gone too far to the right, i.e. if it's self.canvas.width, if it's exceeding that, then we want it to go the other way. So simple as that. Let's run it, see what happens. F5, and it seems that error x1 not defined. Whoops, I forgot to delete our array, my bad. So Command S, F5. Awesome. So now we have a ball that is bouncing in a square box. Wow. So now you must be wondering, but that's nothing. I want to create my game. But yes, but we have to take things slowly. But this is actually quite cool. Awesome. So now the ball won't go out at any wall. It'll just keep on bouncing. Great. So now we have a bouncing ball and our code is looking pretty good. We have learned a lot. So let's do a quick recap. Let me close this and let me minimize this. So all we did in this lecture is we created constraints. So we call the function chords, and we said that the chords results gives us an array x1, y1, x2, y2. And all we're doing is we're checking to see where the ball is. If the ball has gone beyond any point, then we want to reverse it and make it go the other way. And by doing that, the ball will stay in our canvas. Over here, to get the canvas height and the width, we call the functions winfo underscore height and winfo underscore width. Awesome. And to give the ball a random direction, all we did over here is said, created an array, -3, -2, -1, blah, blah, blah. And then all we said is shuffle it up and then give me the first value. Great. In the next lecture, we'll be creating our paddle, moving our paddle, and then we'll create some more animations and make our game a little more lively. Awesome. See you in the next lecture. Hi there. This is the part 3 of creating our bounce game. So in this lecture, we'll be creating our paddle. So under the class ball, let's create a new class. So class paddle. I'll hit enter there. Awesome. Class paddle. And it's going to be initialized almost the same way as our ball, but with a few changes. So def initialize or init self canvas color. Awesome. We're going to say self.canvas is equal to canvas. Self.id is equal to. And now there'll be a small change over here. So we're going to be canvas.create rectangle. Obviously, our paddle cannot be an oval because that won't make sense. But, you know, you never know. You could create an oval. Canvas.create rectangle, and our size, let's make it 0, 0. And then 100, 10. So a nice thin paddle. Then what we're going to say is we have to fill the color too. Don't forget that. So comma fill is equal to the color that was provided. All right, great. Now what do we have to do? We have to create self.canvas move. And where do we want to move it? Let's move it to this place. Self.id. So give the ID. Where and where 200, 300, and then let's create one more function like we did with the ball. Def draw takes the parameter self, and then we're just going to put pass there for now. Awesome. Command S, F5. But before we do that, let's do one more thing and add the this over here. Let's add the paddle.draw function. Great. Command S, F5. And what do we have? We don't see it. And why is that? Because we have not initialized it yet. So we have a ball, but we don't have a paddle. So let's create paddle is equal to paddle class, passing in canvas, and let's have this, I don't know, a blue paddle. Now this can be completely up to you. You can change the colors however you like. I'm just going with the standard. All right, and awesome. So we now have our ball and we have our paddle. So it's giving me an x1 not defined. I guess I haven't deleted the array yet. Sorry about that. So Command S, F5, and now we should have a ball that bounces and the paddle that does not move. And if the ball goes or hits the paddle, it'll just go through. So we need to make a few changes to our program. It's not ready just yet. Alright, but now we have a ball and a paddle, so that's great. Let's close out of this. Stop. Yes. Okay. First thing first, we have to make the paddle move. Because if the paddle doesn't move, there's no point in playing the game. So let's add two functions to our paddle class. And they're quite simple functions. Def turn left. So moving the paddle left. It's going to take two, self and EVT, or event for short. And we're going to just say here, self.x should be -2. And def turn right. So if you want to make the paddle move right, self comma event colon self.x should be equal to 2. But we haven't even initialized the x here, so let's initialize the x. Self.x is equal to 0. So right now it's stationary, we're not doing anything with it. Great. We also now have to update the draw. So before we do that, we will bind the key press left and the key press right. Alright, so we now have our self.x and we've created this. Let's now bind the keys. So before doing that, let's get our width. We need the width so that our paddle doesn't go off the board. So self.canvas.width is equal to, or underscore width, sorry, is equal to, and what was the function? Self.canvas.winfo underscore width. Great. Now let's bind the keys. So remember, left key and right key, nothing too hard. Self.canvas.bind all. Just remember, we learned this in a few lectures ago. Self.canvas.bind all. Key press left. Key press left. And comma, what event will we be doing? It's self.turn left. So remember, it's composed of two things. One is which key are we binding, and remember the alligator mouth, sorry. So what key are we binding? We're binding the left key. And what are we binding it to? We're binding it to the function self.turn left. Now the same way, I'm just going to do Command C and Command V. It's just going to save me some time. Key press right. And what is that? Self.turn right. Voila. Command S, F5. Let's see what we have. Unexpected indent. So it's giving me an error. Let's see where. Over here. So it looks like when we were copying and pasting, that might have accidentally come. F5. And look at that. So our paddle is not moving, but we have the bouncing ball. That's interesting. Let's close this and take a look. So self.x, and the reason why, if you don't know already, is because in our def draw, we haven't moved it yet. So there's no point in giving the functions if we're not moving our paddle. So let's quickly add that in. Self.canvas.move. It's just like the ball, so don't worry. Self.id. So what are we moving? It's the ID. And where are we moving it to? Self.x, and we're not making go up or down, so it's going to be 0. So self.canvas.move, self.id, self.x, 0. Great. Now, just like in the ball, we'll be taking the coordinates. So position is equal to self.canvas.coords. And what are we taking it off? Self.id. I'm going through this a bit fast, but if you have any complications, just look in what we did with the ball. It's the exact same thing. Now, right now, if you don't add this code, let's just try running it to see where we are. F5. And now we have a paddle that moves, but the problem is, one is, whoops, the ball went right through, and two is the paddle went right out of our screen. So we have to fix those two instances. The first one is easy to fix. We have to first make sure that the paddle stays in the screen. So to do that, we're going to say if position 0 is less than or equal to 0. So remember in our array x1, x1, y1, x2, y2. So if our leftmost edge of the paddle is at the leftmost part of the screen, then we're going to say self.x should be equal to 2. And if position 2 is less than or equal to or greater than or equal to our height, so self or width in this case, sorry, self.canvas width, all we want to say is self.x is equal to -2. Or actually, no, we don't want this. We don't want the 2 or the -2. We want to keep it 0. It should be on user input that the paddle goes back and forth. Obviously, if it hits the edge, the paddle should stop moving. So Command S, F5. What do we get? So the paddle moves, nothing happens. But if it hits the edge, it stops. And if it hits the other edge, it stops. Okay, great, awesome. So let's close this up, great. So now we have a paddle, and the paddle is able to move both left and right, and it'll stop if it reaches the left end or the right end. Awesome. So right now, if you notice, you have to click the canvas before the game recognizes the left and right key actions. Clicking the canvas gives the canvas focus. So if we don't click the canvas, it won't know that it's selected. Like right now, my bounce or my IDLE is not selected. So if I try typing, nothing comes. As soon as I type, then it realizes what we're doing. Great. So now we have to find out when the ball hits the paddle. But we'll be doing that in the next lecture. So in this lecture, we learned about creating our class paddle and making it stop when it hits the left and right and binding our keys together. In the next lecture, we'll be dealing with finding out when the ball hits the paddle. See you in the next lecture. Hi there. In the previous few lectures, we've been working on our bounce program. So we've got to the point where we have our paddle, we have our ball. The ball seems to be moving quite well, and the paddle moves left and right, and nothing is going out of boundary. The next thing we need to do is find out when the ball hits the paddle. At this point in our code, the ball won't hit the paddle. In fact, the ball will just go through it. We can solve this problem by adding the code to the draw function, where we have code that checks for walls. But it's a better idea to move this sort of code into new functions. So we'll first change the ball's init function, so we can pass the paddle object as a parameter. So let's go back to our ball class and let's pass paddle, let's pass it in between actually. So canvas, paddle, color. The next thing we need to do is initialize it. So after the canvas, let's do self.paddle is equal to paddle. Before we get any further, let's make this a little more neater because I'm getting confused what is what. So let's add a few spaces to separate some stuff out. All right, great. So we have now initialized our paddle in the def init class, and self.paddle is equal to paddle. Great. Next thing we need to do is change the ball class. So right now it's only taking the canvas and red. In it, let's just add paddle. But we'll get an error doing this because first the ball will get initialized, and while it's reading it, you'll see paddle, but it'll be like, what is paddle? I have no clue. That's because our paddle line is over here. So just Command X and do enter and Command V. So paddle should be first and then the ball. Great. The code we need to see if the ball has struck the paddle is a little more complicated than the code to check for walls. Let's call this function hit paddle. And let's go up to the ball class and let's create a new function, def hit paddle. Okay, so let's add it in. Def hit paddle. Actually, you know what? Let's initialize this before the draw function. So def hit paddle. It should take in two things, the self and the position. Now, one thing we need to do is first let's put a pass here. Let's say the ball hit the paddle. Then what? We have to make it so that the ball goes backwards in the direction it was going. So let's quickly add that in our def.draw. Let's say if self.hit underscore paddle, taking in the value pause, is equal to true, we're gonna say self.y is equal to -3. So let's explain what just happened here. All we did was created a function. We call it hit paddle with two parameters, self and the position of the ball. So we're saying self.hit underscore paddle pause is equal to true. Then we want the ball to go in the reverse direction. And here pause is the coordinates of the ball. All right. So we have that much. So let's remove the pass and let's start coding if it hits the ball. So follow me. Just copy what I'm going to write. Paddle pause. So the position of the paddle should be equal to self.canvas.chords. Chords, and then what is the ID? It's going to be self.paddle.id. Great. So now we have the paddle's coordinates and we have what? We have the ball's coordinates. So now this code will be a little more confusing. So once I write, I'll explain it to you. So just follow me. If pause2 is greater than or equal to paddle pause 0, then what do we want to do? And pause 0 is less than and equal to paddle underscore pause 2, then we want to say another if statement. If pause 3 is greater than or equal to paddle underscore pause 1 and pause 3 is less than or equal to paddle pause 3. Now you must be totally confused, probably have no idea what's going on. I'm going to try my best to explain it. Else return false. So we want to return false over here. Return false. Okay. So if you didn't get what just happened, I'm just going to explain it to you right now. If you got it, great. If not, don't worry. So in the first line, we initialize the function hit paddle taking two parameters. At the second line, paddle pause, we're just getting the coordinates of the paddle. Great. At the third line, we have the first part of our if statement. If pause 2 is greater than or equal to paddle pause 0 and pause 0 is less than or equal to paddle pause 2. Now we're saying here pause 2 contains the x coordinate for the ball's right side. And paddle pause 0 contains the x coordinates for the paddle's left side. So visualize it like this. Consider this to be our ball, like my pointer is the ball, and let's say return false as the paddle. So the rightmost side of the ball, we're saying position 2, so the rightmost side, if it is greater than or equal to the left side. So if to say this in simple English, all we're saying that if the ball is further to the right of the left side, then do something. So if you didn't get that, let me try explaining one more time. The variable pause 2 contains the x coordinate for the ball's right side, and pause 0 contains the x coordinate for the left side. Paddle pause 0 contains the x coordinate for the left side. Now, if you think about it, so let me just run it and try to show you. So we have our Python launcher. Alright, that's fine, let it load, that's okay. But the main concept I'm trying to show you here, the left side of the paddle and the right side of the ball. So if the ball's right side is greater than or equal to the left side, i.e. if you think of this as a long line and this as a long line, then it should be here somewhere, to the right of the right side. So right here, right now, the ball was here. So right now, all this is true. So this function returned true. And right when the ball got here, the function returned false. So if position 2, if the right side of the ball is greater than or equal to the left side of the paddle, and the left side, or position 0, so if the left side of the ball is less than or equal to the right side of the paddle. So all we're saying here is, if the ball's right side is more than the left side of the paddle, and the right side of the ball is less than the right side of the paddle. Okay, I agree. Again, confusing, but hopefully you got it. Think of the board, or think of our paddle as a huge long column. We're just checking to see if the ball is in that column or not. So by using this, position 2 greater than or equal to paddle pause 0, and pause 0 less than or equal to paddle pause, we find out if the ball is in that column. Doesn't matter where in the column right now, but if it's in that column, right of the left side of the paddle and left of the right side of the paddle, so i.e. in this space, then we go on to the next statement. If position 3 is greater than paddle position 1. So what is position 3 of the ball? It's the bottom side, so the bottom. And we're checking to see if position 3 is greater than or equal to paddle position 1. And what is paddle position 1? The top of the paddle. So we're checking to see if the ball has either hit the top of the paddle, or if it's gone a little bit under. So it might be a little 1-2 pixels down, but if the ball has gone through the paddle, or if it's hit the top, and position 3. So position 3 is the bottom of the ball, and we're checking to see if it's less than or equal to the paddle position 3. So in the first if statement, we were checking to see if it was in this column. In the second if statement, we were checking to see if it's in the width part of the paddleboard. So stick with me here. We're saying if position 3 is greater than or equal to paddle position 1. So we're checking to see if the bottom of the ball has gone past the top part, but we're also checking to see if the position, or if the bottom of the ball has not gone past the bottom part. So it's between the top and the bottom. Alright, hopefully you got that. If not, don't worry, but we'll repeat this. I'll do a recap and I'll try to explain one more time. So all we're saying now is return true, and else if this if this part is not true, then we're saying return false. So hopefully you got that. Great. Awesome. So based on this, we have now successfully ran it. So let's close this and let's do F5 again. Command S, F5. And our Python launcher. Okay, let's try moving our thing. Let's click this. Wait. Come on, we missed. Okay, wait. So let's do this. Let's wait for the ball. Ta-dun, ta-dun, and boom. Wow. Awesome. So right now our ball has just hit off the paddle. Let's try hitting it one more time. Great. So if you didn't understand the code, number 1, we're checking to see if the ball is in the column, so the lengthwise part of the paddle. And then the next part of the if statement, we're checking to see if the ball is in the width part of the paddle. So we hit it. Great. Awesome. Now, right now you must be noticing that no matter what, the ball isn't dying. There's no end to the game. Obviously, a game must have a chance or something like that. So we have to check to see if the ball hits the bottom. And if it does, we have to pause the game and say someone has won. So let's fix this. Close this out. Let's close this out. Okay. So we have to add the element of chance, right? Right. So we need to add a hit bottom object, or a hit bottom variable, to the ball's init function. So let's go up. we have the ball's init function. Let's add one more variable. We're going to say self.hitBottom. Hit bottom is equal to false, right? And now all we're going to say here, so remember, where are we saying if the ball hits the bottom, make it 3? We're saying it over here. Self.canvasHeight, we're saying -3. We don't want to say this is -3. We want to say self.y is equal to 0. And then we want to say that, actually, let's not even say self.y is equal to 0. All we can do is say self.hitBottom is equal to true. So it has hit the bottom. And last but not least, let's go back to our while loop. And we're going to say over here, while 1, if hit bottom, or ball.hitBottom, my bad, ball.hitBottom is equal to true or is equal to false. So if it has not hit the bottom, we want ball to be drawn and paddle to be drawn. Else, don't do it. So don't draw, don't change. So the final change that we did this. We made this as in the draw function. We said here that self.hit_bottom is equal to true. So Command S, F5. Hopefully this will work. Let's see. Alright, so I'm just going to miss. I'm not going to do anything. And the ball hits the bottom and it stops. Great. So this is huge, guys. We have now created a fully functional bounce game. I remember it was just a few lectures ago. We were dealing with Hello World. Look where we've come. This is amazing. Now I agree, this game is not that functional. It's just a paddle and a ball. I'm sure you can create a better version of this. So let's think of more things we can do. So we can create many things. We can, first of all, delay the game start. So we can, pause the game, give it a counter. Number 2 is we have to give a proper game over. So right now the ball just hits the bottom and we're not showing anything. So you can use that with the create text function. So canvas.createText. Game over. It's quite simple. Actually, let's just do it. I'm not even gonna say anything. So let's just do it. Let's go back. Let's close this. Okay. So let's go over to where we're saying this thing. Self.hitBottom is equal to true. And what do we want? Alright, so let's add our create text function to our ball def.draw. So we're saying that if self.hitBottom is equal to true, we want to create some text. So the function for that, canvas.createText. And to do this, it takes 3 parameters. The first parameter is the x coordinate and the y coordinate. I'm just going to do it where we positioned our ball, so 245, 100. And then the third parameter is the text. So text is going to be equal to game over. Command S, F5. Let's see if this works. We have our Python launcher loading. Okay. So now, as you can see, our ball is moving really slow. I think we can speed that up. So, alright, awesome. So now over here we have our game over. Great. So now I can proudly say we have created a fully functional game. Hopefully you've enjoyed this course and hopefully you enjoyed creating this game because I've had a lot of fun myself. Now there's many things we could have done with this. If you've ever played that game, Brick Break, I'm not sure what it's called, but there's like a line of bricks up top and the ball hits it and the brick disappears. Well, this is my challenge to you. So I want you to create another class, and then that class can be a brick or a random block, whatever you want to call it, and just start off with 1. So try creating 1 block, and when the ball hits the block should disappear and the ball should come back, like we did with this paddle, the exact opposite. So, yep, this is the finale to our game. Now, there's also the score, so we can add a score. Now, that'll be the same thing. We'll be updating our text. So every time the ball hits this, or every time a ball hits one of those blocks, then you can increase the score and whatnot. Now, this is all up to you, but fantastic, guys. So we have now created a fully functional game that I'm sure you must be proud of, or at least I'm proud of. All right, I'll see you in the next lecture. Hi guys, in the last lecture we created our very own bounce game, and that's one huge achievement to be proud of. So this lecture is just going to be a recap. It's going to be quite quick. In case you already got everything we did, you can just skip it. Otherwise, I'm just going to go through once more everything. So we created our Tkinter, we imported all of these things. The resizable made sure we cannot resize the window. Topmost basically means that our window should appear first, like it shouldn't be hidden under any other window. And the canvas is equal to canvas part. We created our own canvas with no border and no highlight thickness. We packed and we updated. This was all simple, hopefully you got that. Now comes the object-oriented programming. We talked about a little bit in the previous lectures, but if you didn't get it then, hopefully you got it now. We created a class ball, and with the ball, we created three functions: def init, def hit paddle, and def draw. So we passed some parameters: canvas, paddle, color, and each had a self.canvas and self.paddle so that we could tell what each one means. Then to make the ball move someplace else, not always move off, going straight, we created a start is equal to an array, shuffled it, and then said self.x is equal to start 0. Now x and y are the x and y values for the move function. So over here, self.canvas.move, we're passing in the self.x and self.y. This was our hit paddle function. All we're saying over here is if the right part of the ball has passed the left part of the board, and the left part of the ball has passed the right part of the board, and if the bottom part of the ball has passed the top part of the board, and if the bottom part of the ball has not passed the bottom part of the board. Okay, a little bit confusing, but it's quite simple. We return true, otherwise return false. So now we had our def draw, and then def draw we're just saying these were all the walls. So if it hit the top, then make it go reverse. If it hit the right, make it go reverse. If it hit the left, make it go reverse. And if it hit the bottom, make it go reverse. Position was our getting the coordinates from our ID. That was pretty cool. Great. Now def init self canvas color. That was our class paddle. And we did the bind all. We binded our keys with these two functions, self.turn left, self.turn right. We created our draw function, and in our draw function, we did if position 0 is less than or equal to 0, we didn't want the board to go past that, and we didn't want the board to go past this. Here we're just saying def turn left, self.x should equal to -2, and turn right, x should equal 2. Normal left and right values. Here we're initializing both a paddle and a ball. And over here in our while loop, we're saying if the ball has not hit the bottle, draw the ball, draw the paddle, and then update, refresh the canvas, and then sleep for the animations. Awesome. So this was huge. You should be immensely proud of what you've just accomplished. I'm immensely proud of what we've just done. Great. I'll see you in the next lecture. Hopefully you understood this whole program, and I hope you had fun doing it. End the lecture, and that's that. The file that I've uploaded for this bounce is going to be a bit different. So if you take a look in my bounce file and try running it, you'll see that it's much more advanced. It has background colors, everything has been colored, and it even has some blocks too. So you can take a look at the code I've done, copy that off, try to understand it. If you have any problems, just notify me and I'll get back right to you. Awesome. See you in the next lecture. Hi guys, in this lecture we'll be creating one more fantastic game. I'm sure you must have played that air hockey on the table, right? We'll be creating a game something like that. We'll be calling it Pong. So let's close our bounce application, open up a new IDLE, and expand this. And let's create a new file. Whoops, we shouldn't have expanded that actually, because, file, new file, and let's save this as Command S and Pong. Great. So this app will be somewhat similar to our bounce app, but in this case we'll have two paddles. So this is going to be a two-player game. Once we're done, I'm pretty sure you can show off to your friend or someone. You can play it with them and have some fun. Now the concept is going to be quite simple. There's going to be two paddles, one on the left side, one on the right side. In the middle, there's going to be a line. The background is going to be black, and there'll be a ball. And that ball will move back and forth between the paddles. If it hits one of the ends, then what? Then it goes to a point for the other person. If it hits the right end, then it's going to be a point for the left person. And the first person to get to 10 wins. So the concept is quite simple, but the coding is going to be a little more difficult than the last one. So first, let's import the modules that we need from tkinter. Import star, import random, and import time. Great. Next thing we need to do is we're going to be creating our canvas. So it's straightforward. TK is equal to TK. And before we create our canvas, we'll be doing some stuff. Let's first create our title. Is going to be Pong. Awesome. And then we'll be creating tk.resizable. So basically, whatever we did in the last lecture, we'll be copying that. tk.wm attributes. Quotation marks topmost, and then comma 1. Awesome. Canvas is equal to canvas tk comma width comma is equal to 500, and height is equal to 500. Or actually, for our game, we're going to be doing a 400. Border should be 0, and our highlight thickness is going to be 0. So if you want, actually, let's just open up our previous bounce application. So let's open this up. Bounce, not in text edit, but let's open this up in. That's fine. So here we have our bounce. If you want for a reference to see what we did, so we'll just be copying the beginning part at least. So we're going to do canvas.pack and tk.update, or we'll doing, okay, sure, tk.update. Great. So if you run this, you'll see, or let's just run this for the sake of running. Save this. And we get our Pong. So this is our interface. Now, there's a few edits that needs to be made. So let's first create our user interface. First thing first is there's one part about the canvas I haven't told you about. It's called item config. So I'm going to say canvas.itemConfig. Now with this item config, you can change a lot of stuff. Let's say you wanted to change a color from green to yellow. You'll say that item.itemConfig, and then in brackets, color equal to blah. So for now, what we're going to do is we're going to change our background color to black. So we're going to say BG is equal to black. Great. So Command S, F5, do we have a black background? Yes or no? It says missing one required positional argument, tag world. Now, what does that mean? I'm not sure. I found the reason. Item config is not with canvas. Item config is with different items. We'll be getting to that quite soon, actually. Sorry about that. It's canvas.config. So we're configuring the canvas to have a background called black. Let's run this, F5. And do we have a black background? Awesome. So now our Pong, as you can see, has a black background. Now, the next thing we have to do is we have to create a line in the middle. So we're going to say canvas.createLine in brackets 250, 0, 250, 400. Sorry, 400. That's our height, remember? And then we're going to say fill is equal to white. Command S, let's run this to see what we have. Awesome. So now this is going to be our interface. We'll have one paddle over here, one paddle over here. The ball will start in the middle, and that's going to be pretty much it. And then we'll code our game. So let's create a new class. That class is going to be called class ball. So like our previous one, class ball, we're going to initialize it, but we'll be initializing it the same way as well. Def init, we'll be taking 3 parameters, canvas and color. All right, let's put a colon, my bad. And then we'll say self.canvas is equal to canvas. And then what? We're going to say self.paddle, or actually we don't have a paddle yet, so let's wait. But what we can do is we can create our ID. I'm sorry, self.id is equal to canvas.create oval. So you know what, let's just copy the same code that we had over here. So it's gonna be oval, but right, so 10 comma 10 comma 25 comma 25, and we're gonna say fill is gonna be whatever color you wanted, so color. And then we're gonna say self.canvas.move self.id, and then we want to move it to 240 comma 260. So Command S F5, let's see what this does. That's right, we haven't initialized our this thing yet, so let's first initialize our ball is equal to, or let's do lowercase, ball is equal to ball, parameter should be canvas, comma, color, so let's just make this orange, so orange, and then let's create a while one statement, so while one, canvas dot update. And then what was the other two that we used? Let me just check. Sorry, it wasn't canvas.update. It was tk.update, tk.update, idle tasks, tk.update, and time.sleep 0.01. Great. Command S, F5. Let's see if we can get a ball. Awesome. So our ball's arrangement isn't really where we want it to be. We want it to be in the middle, but it's down below. So let's kill it. Yes, we want to do it in the middle. So what would the middle be? It would be 190 to 210, I believe should work. F5, let's see if that works. So that's given it over here. So okay, I got it. We're gonna be doing, so 200 or 200, 250 comma 200. Try that. That should work. That should get in the middle. Source must be saved. Okay. Off by a few. That. So let's try. Click OK. Just follow our line. I'm not sure why it's not doing that properly, but let's just try 240. Will that work? Sorry about that. All right, let's do 235. So 235. Hopefully this should be the last time we're going to do this. Yeah, good enough. So now we have a ball. It's in the middle of the line. That's where we wanted it to be. Great. So I'm just going to go to our here. All right. So we've now initialized our class ball. We have it in the middle. Now let's add some movement. So let's create our def move. So like always, or the def draw. So def draw should take the parameter self. And all we're going to say is self.canvas.move, self.id, self.x, self.y. We have to initialize those variables here as well. Self.x is equal to 0 at the moment. And self.y, I think we'll just do it the same as well. So self.x is equal to 0 and self.y is equal to 0 as well, before we get the ball to actually move. And then, if you remember, we have to add the parameters as well. So first, let's add the top and bottom parameters. So we're going to say, let's just copy off this. So if position 0, okay, actually let's just go up and copy this. So if position 1 is less than 0, so Command C, Command V, great. And if position 3, let's copy that line, we don't want the other line, is that, then we want to say self.y is equal to -3. So hopefully you got that. All we did is we set the parameters. If the top of the ball has gone beyond the screen, bring it back. If the bottom of the ball has gone beyond the screen, then bring it back. So let's start shooting off our ball. So let's create a list. Starts is gonna be equal to same thing, but in this time -3, 3. And self.x is gonna be, well, let's shuffle this up first. So random.shuffle starts. Self.x should be equal to starts 0, so either -3 or 3, and self.y should be -3. Let's give it a starting value. Alright, great. So we did quite a lot. Let's see F5 if this works. And we have a running program or not. So nothing seems to be happening. It's not drawing. Let's see why. Hopefully you should have guessed the answer. If not, don't worry. We have to update. So we have to say ball.draw. Simple as that. Command S, F5. And does it work? No, it's giving us an error. Name position is not defined. That's right. We forgot to initialize our position. So position is equal to canvas.self.canvas.chords. And we'll pass in the self.id. So there we go. Now this should work. F5. Does this work? No, it's giving us another error. Ball object has no attribute canvas height, obviously. So I guess we're missing a lot. I'm sorry about that. I forgot. So self.canvas_height. Let's initialize the variable is equal to canvas dot, what was it? It was WinPro. Self.canvas dot self dot canvas dot winfo self.canvas, sorry about that, .winfo height. Great. So now we have initialized our height. Command S. Let's try running this. Hopefully it should work. It shouldn't give us an error again. Great. So our ball hit the side and went off the screen. So let's quickly write the program to get the ball bouncing again. So it's bouncing everywhere. So let's just say if position 0 is less than or equal to 0, then we want to say self.x should be equal to 3, and if position 2 is greater than, so let's also create the width. So self.canvas.width is equal to self.canvas.winfo_height. So basically, so far, whatever we did in our bounce application, we've just copied that because the ball framework should be the same. Obviously, we'll be changing this stuff later on, but for now, it's fine. So if position 2 is greater than or equal to self.canvas_width, let's change that. Sorry, it shouldn't have been a dot. Alright, then what do you want to do? We want to bring x back. So self.x is equal to -3. Command S, F5. Let's take a look, and we have a bouncing ball. Would you look at that? So our ball seems to be bouncing early. It's not going all the way. Now, why is that? I have no clue, but let's see. So let's go back over here, close this. What have we done? We have created our canvas, which was a height width 500 and height 400. And we're saying over here self.canvas.winfo height. I guess in case this error happens to you, let's just say self.canvas_width is equal to 500. Let's not even use that function. Obviously it'll still work. Let's see if this works. There we go. So now it's going till the end. It's going to the end, and we have a ball bouncing in a box. Great. In the next lecture, we'll create the paddles and we'll program them, and we'll get further into creating our Pong. Sounds good. See you in the next lecture. Hi guys. In the last lecture, we left off after creating a ball and letting it move around in our board, you could say. So in this lecture, I plan to create two classes, Paddle and Paddle 1, and we'll program them to using the bind all function to make them go left, right. Now, obviously, only one of the paddles will be able to use the left, right function. So for the other one, we'll program it with the A and D keys. So left, right for one paddle and A and D for the other paddle. All right, sounds good. Let's close this. Close this. So after our class ball, let's create a new class. Let's call it class paddle. And we're going to be initializing it probably almost the same as we initialized our other class. So def init, we're going to say self, canvas, and color. What color should the paddles be? So we're going to say self.canvas is equal to canvas, and self.id is equal to canvas.create rectangle, and 0, 150, 30, 250, and fill is equal to color. Now I won't be using the self.canvas move as we've done before, because the way I initialize my canvas.create rectangle, it'll automatically position the rectangle where I want it to be. Great. Now let's create our .y variable. So self.y, because the only thing our paddle will do is move up and down the screen. So self.y is equal to 0. And we want to create our self.canvas height. Canvas height is equal to self.canvas .winfo underscore height. Great. And then you can initialize our width as well. Self.canvas width is equal to self.canvas.winfo underscore width brackets. Great. So now we have our two variables. Now, before we do that, let's create our draw function. So def draw. And in it, we're just going to pass the value self. We'll just be saying, first let's get a coordinates. So self.canvas.move. So let's move it, because obviously this is going to be the animation part. Self.id, comma, 0. So remember, the x value should not move. It should only be the y value. So self.id, comma 0, comma self.y. Great. So now let's create our coordinates. Position is equal to self.canvas.coords, self.id. Now, if you think I'm going a bit too fast, I'm sorry about that, but you should probably know all of this by now. If you don't, just look back over to our bounce lecture where I explained everything. Right now, I'm just getting through this so that we can have a working application. Anything that's new, I'll explain it definitely. And if not, you can always send me an email, or in the questions section, you can always ask me the question. So now we have position is equal to self.canvas.coords, self.id. So we want to check to make sure our paddle does not go too high or too low. So it's going to be if position 1 is less than or equal to 0, then we're just saying that if the top of the paddle has gone past the top of the board, we want to say self.y is equal to 0. We don't want the paddle to move anymore. And if position 3 is greater than or equal to 400, then we're going to say self.y is equal to 0. Command S, let's save that. Down over here, let's start saying paddle. So let's first initialize the class. Paddle is equal to paddle canvas, and you can do whatever color you want. I'm just going to do white for now because white looks awesome. Ball.draw, paddle.draw. Hopefully we're not missing anything. Command S, F5, let's see. And so far, no error. Great, so now we have a paddle, as you can see. It's not going to be responding to any of our keys yet, and the ball is going through. But we have a paddle, so that's awesome. I actually don't like the white color. We can change it. So let's make this, let's make it a blue paddle, because blue is awesome. All right, so now we have a paddle, and we are not moving it right now, so let's get it to move. So it's going to be def move or turn left. So basically the code we used in the last lecture. Self, evt, And all we're gonna say over here is this. So we want to check. All right, so right now we're self.left should make it self.y is equal to, well, let's see here. So left would be going up, so self.y should be -3, and def turn right, self.event self.y should equal to 3. Now hopefully I got this right. I'm not completely sure, but I think this should work. Yep. And before we do anything, let's first bind our keys. So let's go and get the A and the D. So let's go over to our initialization section, and we're gonna say over here self.canvas.bind all, and it's gonna be the letter A, comma, self.turn left, and self.canvas.bind all, B, or no, it's gonna be D, comma, self.turn right. Wow, so this should now work. Command S, let's run it, F5. So let's click this. Is it running? No, it's giving us an error. Name bind all is not defined. So let's close this and see. Okay, we put a comma over here. That's why it's not working. So Command S, F5. And is it working? A and D. Okay, look at that. So our paddle is now working. As you can see, it goes up and it goes down. So down, up, down, up. If the ball hits, it's just going to go through. Awesome. So we have a working paddle on the left side. It's time to create one on the right side. In the next lecture, we'll create the paddle on the right side and then add the functionality if the ball hits either paddle. See you in the next lecture. Ball and one moving paddle. In this lecture, we plan to create one more paddle and then we'll add the functionality if the ball hits the paddle. So let's close our Pong, let's close our shell, and then let's create one more class. That class is going to be called paddle1. So in here, I'm not going to be changing too much. So it's going to be the same thing, def init self dot comma canvas comma color, so canvas color colon, and then we're just gonna do what we did before. So self dot canvas is equal to canvas, self dot id is equal to canvas dot create rectangle, and then it's going to be the coordinates of that is 470, 150, 500, 250. So again, these coordinates have been pre-arranged so that it'll be the placement right, so we won't be adding the self.move. And then the fill will obviously be the color. Great. Now we have our ID. We have to create the self.canvas height and self.canvas width. Even though we didn't use it, it's okay to create it. So I'm just going to copy and paste these two from above. You should probably do the same. It'll save us some time. Great. Then let's create our self.y value. Self.y is equal to 0. Awesome. So let's create our draw, def draw, and it takes our parameter self. So it's going to be the same functioning as the above one, so we can just copy this because it is the exact same. Command V, so we're just saying if the top has gone past the top of the module, then bring it back, and if it has gone below, then bring it back. So simple as that. Now let's add our functionality for the def turn left and the def turn right. So def turn left should be for self, avt, and what we're gonna do here is say self.y is equal to 3. So this is gonna be a little bit different than this because if you think about it, once we play the game, you'll understand why we're doing that. And the next one should be def turn right, self, evt, self.y should be equal to -3. Now let's bind all. So let's copy these two. Command C, and then enter Command V. So instead of A, it's going to be key press left and key press right. If you remember from our lecture, from a previous lecture, we did the exact same thing. So key press right. Great. Command S, Command S. This should potentially work. Let's hope it works. Cross our fingers. We forgot some of the most important steps. How could I forget? Go over here. Let's initialize our paddle. Paddle 1 is equal to paddle 1 canvas. And if you want, I'm just going to create a pink paddle. I mean, that looks cool. And then let's do paddle.draw. Command S, F5. So we now have a blue and a pink paddle. It'll look pretty cool. I have to click on this, so let's click. The right and left keys don't seem to be doing anything, but the blue paddle is still moving. So let's take a look at what we did wrong with the pink paddle. So close this, let's take a look. We're saying self.y is equal to 0. What's different here? So while writing, I guess we missed out the 1. It should be paddle1.draw. So Command S, F5. And now it should work. So click on this, right, left, left. So now, this is now a 2-player game, so we can always play this with your friends and have a lot of fun. But great. So now we're about halfway there with creating our game. We have 2 paddles that are fully functional. Now we need the concept of if it hits the paddle, it should rebound. So let's close this. And let's go back to our ball. And we have to pass 2 things. One will be the paddle and one will be the paddle 1. So let's go back down to our ball, paddle, paddle 1. And if you remember what we did last lecture, Command X this, and then put this up top. So Command V, Command S. Great. So we have to create 2 more definitions in the ball class. The first definition will be if the ball hits the first paddle. So def hit or hit paddle. So hit paddle, the first paddle. If it hits paddle, then what do we have to do? It'll be the exact same thing that what we did in our last last program, our bounce program. Alright, so def.hit or def hit paddle, it's gonna take in 2 parameters, self, pos. And all we're gonna say over here is, so pos is gonna be, so paddle position is equal to self.canvas.chords paddle.id. So self.paddle.id. Like within the last lecture, if you want, you can just scroll and just get this. So if hit paddle, and we're gonna change this just a bit. Alright, so what we're gonna do here is gonna say if pos 1 is greater than or equal to paddle pos 1. I'll explain this, don't worry. And pos 1 is less than or equal to pos or paddle pos 3, if pos 2 is greater than or equal to paddle pos, yeah, I know, this is confusing, I'll give you that much. Paddle pos 0, and then last but not least, and pos 2 is less than or equal to paddle pos 2. So if you didn't get that, or you probably didn't get that, I'm going to explain that to you. Just wait. Return true, and if not, return false. Great. So what we're saying here, if position 1, so what is position 1? The top part of our ball. If the top part of our ball is under the top part of the paddle, and if the top part of our ball is above the bottom part of our paddle, then we want to say here, what does pos 2 mean? It means the right side, or it does mean the right side, doesn't it? We made a mistake. We want the left side. So make that pos 0 and pos 0. Now we're just checking to see if the left side of the ball is more than the right side of the paddle. So if the right side of the paddle, if the ball's left side has gone more than the right side of the paddle, and we're checking to see, okay, cancel that. Accurate checking here. If the right side, or if the left side of the ball is more than the left side of the paddle, and if the left side of the ball is less than the right side of the paddle. So if it's between both ends of the paddle, then we want to return true, else return false. So let's create a new if statement here. If hit underscore paddle, and we're gonna give in our pos, is equal to true. What do we want? We want self.x equal to 3. Awesome. So the same way, all right, it's gonna be the exact same, just a few changes. Def hit paddle 1 self comma pos. So I'm just gonna command C this because it's pretty close. I'll show you the changes. Command V. All right. So we have if position 1 is greater than or equal to this, that's right. And if position 1 is less than or equal to 3, that's right. But here we have to change this to 2. Because our paddle, this second paddle is on the right side, we have to check if the right side of the ball is in between those two, not the left side. So make this position 2 and position 2. There we go. Command S. And make sure you change it to self.paddle1.id. Don't forget that. Alright, now let's create another if statement. If hit underscore paddle 1 is equal to true, and then pass in pos, then all we're going to say is self.x is equal to -3. Command S, okay, cross your fingers, hopefully this will run. Click, okay. It seems to give me an error. Hit paddle is not defined. So let's go back here. Where are we saying hit paddle? We're saying it over here. Why is it saying hit paddle not defined? Alright, I think I know what our problem is. So what we have to do is we haven't initialized our paddle or our paddle 1 yet. That might be the problem, so let's try. Self.paddle is equal to paddle, and self.paddle1 is equal to paddle1. So command S, F5. We shouldn't get the error now. Let's try. Nope, it's still giving us the error. Alright. So let's look back at our code. Aha. So we have not called our function with the self. So over here when we're saying the draw, we have to say if self.hitPaddle and if self.hitPaddle1. So command S, F5. Alright, so let's try running this. Does the down and right work? Yes. Okay, let's try hitting the ball. Awesome. So now as you can see, as we move the paddles, the ball is hit, the ball is hit. Great. So now there's a few more stuff that we have to add. So the first one is we need to have a way to create a score. So the score will maybe not, but at least once the ball hits the end, either the left end or the right end, the ball must be centered. So we'll do that in the next lecture. Right now, great job. We were able to create our paddle class, our paddle 1 class, and now the ball is hitting off both paddles. Great. See you in the next lecture. Hi guys. In this lecture, we'll be creating a way to tell if the ball is hit either the left end or the right end. If it does, we'll stop the game and we'll realign or recenter the ball. Alright, let's get started. So let's close this. Let's close our... Alright, so after some troubleshooting, I found out that I'm actually unsure of how to bring the ball back to the center and then repeat the process all over again. So for right now, let's leave that, and instead what we're going to do is, first of all, let's run our application. Alright. And we have it running, so I'm just going to click this, and so right now it is hitting off. So what we're going to do is, if it hits the end, the ball will continue to move, but we'll show a score up here. So that sounds good. Alright, so let's go over back to our program. And now we're going to have to initialize a few canvas.create text stuff. So let's do that. Now what we have to do is let's create a counter for score. So I'm going to create two variables. One is going to be counter and the other is going to be counter1. So self.counter is equal to 0, self.counter is equal to counter1 is equal to 0. So command S, and let's go over here. So we should actually create a score function of our ball class. So all that score function will do is if it hits the side or if it hits, yeah, let's do that actually. So let's delete that, I'm sorry. So let's delete that and let's create a function called score. So def score, and it's going to take two parameters, self, and then it's going to take a value, the value that we'll pass in. So if you don't remember, in a few lectures ago when we were talking about variables and ints, we created global variables. So global variables are basically variables that exist throughout the whole framework. So if I call this variable anywhere, it would still count. So global counter 1. And all we're going to say is if val is equal to true, then a is equal to self.canvas.create text 125, 140 or 40, text is going to be equal to counter. Font is equal to Arial, so put that in brackets. I'll explain what I'm doing, just give me a sec. Arial and 60, and fill should be white. Fill is equal to white. There we go. So basically, if our value is equal to true, canvas.itemConfig, a fill is equal to black. So this is the next line we want to write, canvas.itemConfig, a comma fill is equal to black. So let's go back, and then counter plus equal to 1. And last but not least, let's just copy this line. There we go. There we go. Command S. And then copy this whole thing. Command C. Command V. Now we're just going to say if value is equal to false. Let's change this. So it's going to be 375, 40 instead. And then we're going to say text is going to be equal to counter1. Text is counter1. And this is 375. So, one sec. Alright, so we created a function called def score, and it takes a parameter value. Now that value will be either true or false, so let's add that first. So position is less than equal to 0. We want to say val is equal to true. So, right, we're actually going to call it with self.score is true. And if it's more, then we're going to say self.score is false. So we created a function. It takes the value, which is going to be true or false. We created two global variables, which is going to be our score. If value is equal to true, then what are we going to do? We're going to say A is equal to self.canvas.create text 125, 40. Text is going to be the score, which is counter, and font is going to be Arial, size 60, fill white. Then we're going to use the item config I was talking about earlier. Canvas.itemConfig. What are we configuring? The A, which is our text. And what are we doing with it? We're going to fill it with black instead. Next but not least, we did the exact same thing, but here we did counter plus. We increased our counter, so score was increased, and then we created it again. So hopefully you got that. If not, don't worry. I'll explain this once again. Now, we also have to initialize our counter variables. So what we're going to do is if you scroll all the way up over here, let's just initialize them. Counter is equal to 0. Counter 1 is equal to 0. Command S, F5. And invalid syntax is giving us an error. What is it saying? Global counter 1. That's because that was wrong. Okay. Counter. Command S, F5. Does this give us an error? It shouldn't. And voila. So as you can see right now, we have a bug that it's printing forever and it's not stopping. So let's go back to our val true. Counter plus or equal to 1. And now we're going to have to say, all right. So the main thing that we actually forgot is this. So wait, cancel. The reason why it's giving us so many iterations is when we set.score is equal to true, we also need to add the line self.x is equal to 3. I'm sorry, we shouldn't have deleted that. That was my mistake. So let's actually put this before. Command X, Command V. And then over here, we'll be saying self.x is equal to -3. So Command S, F5. Let's see if this works. And what do we get? We get 0. So it should be actually showing us 1. Alright, interesting scores, but let's see what happens next. 3, alright, that worked. That didn't do anything. 5, so it's skipping weirdly, but don't worry, we'll fix this. Alright, so 7, 5, but our other score isn't even working. Alright, so it's skipping my 2s and the other one isn't working. Alright. So let's see what could be going wrong. It must just be a simple mistake. Alright, here's the mistake. Counter plus or equal to 1, and this should be counter 1 plus or equal to 1, F5. Invalid syntax, and that's because a random this has been pressed. Command S, F5. So 1, that's great. 1, great. So this commendable, guys. I agree we had to do some troubleshooting there. I'm sorry about that. But this is great. So now we have a fully functional Pong app that you could play with your friends, do whatever you want. Now, obviously, this can have a little more functionality. I think the first thing we're missing is a winning statement. So let's go ahead and add that. But let's just play a little bit, have some fun. All right, cool. So I'm going to close out of this. And what do we have to look for? It's going to be here. So while 1, we're going to be saying if, so we want to see if counter is 10, right? So we're going to say if counter is equal to 10. If counter is equal to 10, what are we saying? Ball.x should be 0. Ball.y should be 0. Paddle.y should be 0. Paddle1.y should be 0. So we want nothing should be able to move. So that's all we're trying to do right now. And then what do we want to say? We want so let's create text. So canvas.create text 250, 200, text is equal to congrats player 1. You win. Hallelujah. Great. Comma, we have to make the font. Font is equal to 32. Not font, font. Font is equal to 32. And fill is equal to red. Great. So this is the first or the second step, and we have to do this again. Canvas.create text. 250, comma 215, comma text. Whoops, I missed the brackets there. 250, comma 215, comma text is equal to score colon plus str counter 1. So player 1, no, it should be counter. Counter 1. There we go. And plus, let's try it out. Okay. Plus right. So it should be counter 1 plus, well, actually, let's just do counter plus this plus another str counter 1. And let's put a space so it'll just display the score. There we go. That's what we want. Comma, font is equal to 32. Fill is equal to red. If I were you, I just copy this. So let's just Command C. Hit enter. Back. If, no, just Command V. And it's going to be the same thing except over here, player 2, Command S, F5, invalid syntax, what's wrong? It's saying over here, why is it giving me this error? Let's see, enter. Alright, so I found our error. Our error was that we forgot to put the brackets over here. So now that we've done that, F5, unindent does not match any outer indentation level. Okay, so let's delete that. Alright, so I fixed our error doing some troubleshooting. It was just an indentation error. Alright, so let's try playing our game. So down, there we go, down, alright. So it's working so far. I have high hopes. So I'm just going to close this, and instead of doing 10, because we're not going to wait that long, I'm just going to make this 1 and 1. Command S, F5, and it gave me, so it's automatically going to 2. Alright, interesting. Alright, so the easiest way to get through this problem is, for what I think is, so what we can do now is just say, so, well, it's a bit of a, you know, I wouldn't recommend it, but it'll help right now. So if counter is equal to 1 or counter 1 is equal to 1, then we want to say time.sleep 10,000 or 100,000. So let's see what happens. Now hopefully this works. Awesome. So it did work. Now this isn't the best way to do it, but it works for now. You can go search on the net for better ways to end your game. So let's reset our values back to 10. So if counter is equal to 10, just wherever you put the 1s, put the 10s down. So if counter 1 is equal to 10, back over here, 10 and 10. Great. So let's run our program one last time. All right. One sec. Doesn't seem to be closing. Sorry about that. So we've changed 10 everywhere. Command S, F5. So this is the last time, guys. Fingers crossed. 1. All right, let's play. So let's just play the game. 2. Great. 3. 1. All right, now there's a lot more so this is great. The game is working, fully functional, and once one guy hits 10, it'll work. Now you can have the concept of timer and making it more graphically look nice, but for now, the thing that we've created is amazing. So give yourselves a pat on the back. This is huge. You have a fully functional 2-player game. In the last lecture, we had created Bounce. Now we've created Pong. So awesome job. So this is it for now. I guess I'll see you in the next lecture. Bye. Hi there. Wow. Congrats on making it to the end of the course. But there's much more than meets the eye. There's so much you can do with Python development. The options are endless. There's several websites that can challenge your Python skills, and with your newfound skills, start coding anything you want. Create some cool games, show off to your friends, or integrate Django to your Python code. The options are endless. If you like this Python course, don't forget to leave a rating, and all feedback, questions, and comments are accepted. Keep on coding. Thanks again for taking this course, and I hope to see you in another one of my courses. Bye.